We humans have built our world on the illusion of certainty. We've measured the length, breadth, and depth of our planet. We've put our flag on the moon and reached for the stars. We've tried to explain everything, from the tiniest atom to the entire observable universe. And yet, the deeper we look, the more these foundations slip away. Because for every question we answer, several more spring up. This is a journey through the unknown. From the tiniest threads of the quantum world, much smaller than the atom, to the swirling chaos that is the human experience, to the cold, infinite vastness of the cosmos. This is everything we don't know about reality. And it all starts with the tiniest layer. A layer so small that merely observing it changes its behavior. The quantum layer, where reality breaks down. We begin at the bottom. Smaller than cells, smaller than atoms, a place where particles flicker in and out of existence, where observation changes outcomes, and time might not behave the way we think it does. This is a world beyond what you were taught in school, a place where cause and effect collapse into probability. We thought physics and mathematics could explain everything. Instead, it opened a new door to questions that feel more like riddles. This is the quantum layer, where the rules don't apply and reality starts to fall apart.
When I was a kid, I loved science, but I felt as though there was no point in becoming a scientist. Everything was already invented. Everything we needed to know had already been discovered, right? I mean, we had equations to describe all kinds of things. Pendulums, rockets, cars, you name it. We were building massive things, flying very heavy planes. The only thing else to achieve was to venture further into space, so I wanted to be an astronaut. Then I realized, okay, maybe there is a point in becoming a scientist. Every day I learned some new phenomenon in physics. Regardless of whether I truly understood it or not, I went to bed with the reassurance that this was all there was, and it governed the world we lived in pretty well. If the math didn't work, it's because I did something wrong. And most of the time, I did. Everything was new and I picked it up pretty fast. But of course, as you grow older, you realize there are more and more things that we still don't know. Bottom line is, we don't know a lot of things. This idea of not knowing, however, takes a whole new meaning with quantum mechanics. But first, let us describe what it means for a theory to work and how science is traditionally done. The scientific method is real. Yes, they actually use it. Scientists observe something. Then they try and hypothesize what might be causing things to happen the way they are. In the case of physics, they try and come up with equations that describe the behavior they're observing. That equation is then tested to see how well the theoretical model replicates reality. The more closely it approximates reality, the better the theory. But notice here that I said approximates. You see, when it comes to physics, theories approximate reality to varying degrees. Some are extremely accurate, others not so much. For example, gases are pretty complicated. They're composed of billions of energetic gas molecules that are constantly colliding and interacting with each other. Because of this, a real gas is extremely hard to determine. So instead, people created the concept of an ideal gas. In short, they're approximations. They bend the rules a bit and get as close as possible to the exact value. No gas is exactly ideal, but the concept of an ideal gas is an extremely useful approximation for most situations. For temperatures near room temperature and pressures near atmospheric pressure, so under normal circumstances, most of the gases we care about are almost perfectly ideal. However, for situations that aren't normal, a bit more work is required. Some rules work really well while on scales that we deal with every day, but once we tweak the settings a bit to different circumstances, our rules begin to break. There's a saying, and it goes, all models are wrong, but some are useful. And honestly, I kind of agree with it. Over the past few million years, humans have been impressively wrong about most things. But it's okay. Models aren't perfect, but some are better than others. In the late 19th century, scientists had another such behavior to model. The sun is bright, like painfully bright. In the sky, it's a glowing white ball of fusion. But, as you know, white isn't just white. It represents a small sliver of radiation called the visible spectrum, and is composed of every color you've ever seen. Now, humans and most things that aren't 5500 degrees Celsius emit light too, but we can't really see it with our own eyes. This is where we enter the infrared and ultraviolet scales. Scientists wanted to know why these colors showed, and if we could predict what colors would emit based on the heat of an object. This sounds like a pretty easy experiment. All objects either emit, absorb, or reflect light, but they wanted an object that didn't reflect anything, something that would absorb all light and only show its radiation, a black body. But like I just said, all objects emit, absorb, or reflect light, so a true black body just doesn't exist in nature. Notice how I said a true black body. For all intents and purposes, the Sun, Earth, and other stars and planets are considered black bodies. Remember, models aren't perfect. Now, considering that these objects absorb all light, they should have an infinite amount of radiation to reflect, right? Well, when they applied their classical mechanics, the physics that governed the world at the time, the approximation was so poor that in fact the experiment ended up being dubbed as the ultraviolet catastrophe. You can't have an object with an infinite amount of energy like that. It violates the conservation of energy. Classical physics, it seemed, was catastrophically off. Enter Max Planck. Planck determined that the missing link preventing the blackbody radiation from being modeled correctly was the assumption that energy could be of any amount. Again, if energy could be any amount, then theoretically you could input an infinite value and come back with a solution. To model it correctly, Planck suggested the use of a packet of energy. Instead of continuous energy being sent, it's neatly packaged and sent in finite amounts. And thus, Planck's constant, in the idea of quantization, was discovered, a fundamental piece in the foundation of quantum mechanics. For the first time, scientists understood that energy states are discrete and not continuous as previously thought, which is weird. In the quantum world, you play by certain rules that often seem very, very different from what we're used to. It makes all of quantum mechanics rather unintuitive and confusing subject matter. And while there is merit to that accusation, we must also remember that, much like every other branch of science, quantum mechanics also has its humble beginnings rooted in some very simple ideas. So, what are those simple ideas? And where does that unintuitiveness come from? Well, in my opinion, one of the biggest hurdles in the understanding of quantum mechanics is Heisenberg's uncertainty principle. It is something that we just don't experience in the macroscopic world. It talks about a fundamental, natural limit to which we can measure things. The uncertainty principle states that no matter how accurately or precisely you try to measure something, you can only do it so well. You can never be absolutely certain of a particle's location and momentum at the same time. It comes down to observation, which is strange yet again, because you would think that our measurements should be irrespective of who is looking and who is not. But in the quantum scale, that's no longer the case. Imagine a pool table. There's a cue ball as well as 15 other striped and solid color balls, but let's not focus on the game itself. When you hit the cue ball, it collides with the other balls on the table, making the cue ball then bounce off into another direction until it eventually hits the side of the table. At the quantum level, collisions are happening a bit differently than what you would expect at the macroscopic level. When photons collide, out comes a bunch of different smaller particles that didn't initially go in. Ions, muons, electrons, and other photons. To understand just how weird this is, imagine a car crash. When the cars collide, you'd expect to just see two destroyed cars with car parts flying everywhere. Imagine that once they collide, a table and a basketball come flying out. On impact, there's a complete transformation into something else. It doesn't make sense. Obviously. Also, speaking of electrons, they can be in multiple places at the same time. But once measured, a precise location is revealed. It's okay. Intuitively, this doesn't make sense to me either. But electrons are essentially a cloud around the nucleus of an atom, and only once we measure them does an actual location show its face. When talking about this small scale, our solutions to problems make much more sense as probabilities as opposed to exact values. The actual formula for Heisenberg's uncertainty principle is this. Here too, you see the presence of Planck's constant. The fact that Planck's constant comes up time and time again when calculating things in the quantum realm really reinforces its significance. In a sense, it's self-proving. Because of so many different experiments, we now know the value of Planck's constant with remarkable precision. Now, you may think that you have very little reason to care about the uncertainty principle in day-to-day life, and you'd be kind of right in thinking that. But as we push harder and harder into the frontiers of innovation, even these tiny amounts of uncertainty start to matter. In fact, humanity's most ambitious goals need a level of precision that has never been seen before. The bizarreness of quantum mechanics doesn't stop there. Physicists are now theorizing even more ideas of the multiverse, The idea that multiple universes exist simultaneously, all differentiated by the smallest particles known to man either going this way or that way. That's just one particle. Factor in how many such particles there are and, well, things get too complicated for me to want to explain. The universe, and the events that happen in it, all comes down to probability. We've talked about how quantum mechanics governs the world we live in, but we've really only mentioned the microscopic scale. Does quantum mechanics hold up on the macro scale? Well, it kinda has to. If we use classical mechanics and the values it produces in quantum mechanics, then you should hypothetically be able to take the same quantum mechanics and apply them to larger systems, such as planetary orbits, and still reproduce accurate results. In order for a new theory to take reign, it should be able to explain some phenomena that previous theories explained. In short, it works. This is called Niels Bohr's correspondence principle, and it gives quantum theory even more merit. The more and more we test, and the more and more examples that prove quantum mechanics agrees with classical mechanics, helps let us know if we're moving in the right direction. But classical mechanics doesn't get everything right. In fact, quantum mechanics change the way we view light itself. Something we encounter every day we wake up is something that we're still figuring out even today. Wave-particle duality is a concept that changed the fundamentals of nature forever. Through the work of Max Planck, Niels Bohr, Albert Einstein, and a handful of other quantum physicists, it was discovered that light not only functions as a wave in the spectrum, but also functions as a particle, at the same time. Their existence is intertwined. Einstein proposed that light functions as a particle, photons, a quanta of light deduced from Planck's theories, and it works. Einstein was an amazing physicist, but few people know that he actually won his Nobel Prize for the photoelectric effect, for his involvement in quantum mechanics. It seems as though we must use one theory and sometimes the other, while at times we may use either. We are faced with a new kind of difficulty. We have two contradictory pictures of reality. Separately, neither of them fully explains the phenomena of light, but together, they do. Albert Einstein said that, and he explained it better than I ever could. Two different pictures of reality, two different theories and views of the world come together to explain it all. It's astonishing to think how one constant could reshape the way we see reality forever. We don't know why it's this way, except for the fact that nature intended it to be this way. Constants are seen throughout nature: Planck's constant, the golden ratio, pi, the list goes on. As with most definitions in physics, they seem to be used in a very specific manner. Velocity means something very specific, amplitude means something very specific. The word uncertainty too means something very specific. But it's hard not to feel that this word, uncertainty, hits home differently these days. It is perhaps the most single apt description of the past few months for the entire world. While I don't expect everyone to be as fascinated with the uncertainty principle as myself and most physicists are, I do hope that you can take just one thing away from it. There's always going to be uncertainty in life. Despite our best efforts, there's only so much we can control, and while it can seem limiting, it can also be the cause for hope and excitement. Uncertainty is, after all, a two-way street. Even genetic exactness cannot rule out uncertainty. Genetics are extremely powerful, but there's even a limit to that power. Identical twins can not only have the same exact genes, but can also share the same environment since the day they're born. And yet, they will still grow up to have different brains and become different people. The detailed structure of the brain is partly shaped by genes and environment, but the rest is relatively random. And I use random for the lack of a better word. Nothing is completely understood, our bodies included. What we see now as random could be seen as obvious in 100 years' time. History, as always, is a good example of this. The quantum world is full of random collisions. But oddly enough, all this randomness brings the order that we observe in the world. Science isn't constant by any means, but it is constantly improving. I wish I could say the same for everything else.
In the year 1925, Einstein shared with a student his burning desire to understand the universe. "I want to know how God created this world," he said as they strolled along. "I'm not interested in this or that phenomenon, in the spectrum of this or that element. I want to know his thoughts. The rest are just details." This one conversation expresses the core of Einstein's guiding principle, one that has driven humanity to inquire, discover, experiment, and most importantly, learn about this universe we call home. But what was Einstein really talking about? And can human knowledge ever reach a point where we understand everything? Since the discovery of the world of quantum mechanics in the early 20th century, scientists have been racking their brain trying to understand how it works. Even a century later, we're still not sure how and why subatomic particles behave the way they do. But that's just half the problem. The discovery of quantum theory posed a more serious issue that Einstein, Stephen Hawking, and other world-renowned physicists have been working tirelessly to solve. That challenge can be summarized in one word: unification. You see, modern physics is split into two pillars: classical physics, the physics of Newton, Einstein, and Galileo, which predicts gravity and describes the motion of massive things in our cosmos like stars and planets, and quantum physics, which governs the world of subatomic particles according to its own set of laws and rules. Both pillars describe their respective worlds accurately, but fail when applied to each other's subject matter. Einstein's preoccupation was that there must be a way that these two worlds could reconcile. There has to be a theory that unifies the world of the subatomic with the world of the massive. A theory that can predict, well, everything. Now you might be thinking, so why should we care? Well, a unified theory that can bridge both of these worlds could potentially unlock many of our universe's secrets and answer some of the deepest philosophical and theological questions that we've been asking since the days of Galileo. What are we truly made of? What happened before the Big Bang? Are we living in a multiverse? The unified theory, or the theory of everything, might just have the answers to all of these questions. The universe and everything in it is glued together by four fundamental forces. I made an entire video on these four forces, so if you really want to fully understand all of them, I suggest you check it out. But for the sake of this video, here is the gist of what they do. Big objects like stars, planets, humans, and cats are all governed by the force of gravity. And thanks to Einstein and his general theory of relativity, we now know that gravity isn't a force that magically pulls objects together. Instead, it's the curving and warping of the fabric of our universe, space-time. While all these big objects are governed by just one fundamental force, subatomic particles, on the other hand, are governed by three fundamental forces, as if they weren't already confusing enough. These three fundamental forces are electromagnetic, weak nuclear, and strong nuclear. Electromagnetism holds atoms together, the strong force holds nuclei together, and the weak force is responsible for some type of nuclear decay. These particles, along with their respective forces, make up what we call the Standard Model. The Standard Model describes the world of the very small. We know that everything in the universe is made of subatomic particles, from planets and stars to humans and dogs. We know that all of these things are made of atoms, and atoms are made of protons, neutrons, and electrons. In the 1960s, we discovered that even protons and neutrons are made of even smaller particles called quarks, and electrons from leptons. Using different combinations of these particles and their respective forces, we can build atoms, molecules, humans, planets, and even stars. So it seems that the Standard Model is a comprehensive interpretation of our universe. But it doesn't include everything. The truth is, finding the smallest subatomic particles is only the first step to getting to a theory of everything. The second step would be finding a place for gravity in this model. There are two reasons why gravity isn't included. The first is that when it comes to small particles, the force of gravity is so weak that it doesn't have any effect on a quantum system. The second reason is that we don't really know how to incorporate general relativity, which describes the motion of large objects, into the world of quantum that governs subatomic particles. Many great minds, including Einstein, tried tirelessly. It's said that even on his deathbed, Einstein revisited his notes on the theory of everything and tried one last time to find an elegant solution to explain the fundamental differences between the world of the small and that of the large. But unfortunately, he ran out of time. So that's that, right? While we still haven't found a theory that can explain everything, we have made significant progress, and maybe the most groundbreaking was that of another brilliant mind, Stephen Hawking. In 2014, a movie was made on the impactful life of Stephen Hawking. As a result, Hawking became one of the most revered physicists in the world, and one of the most admired by pop culture. Away from the limelight, however, Hawking, like Einstein, had an obsessive yearning to understand the universe and never ceased to challenge our knowledge of it. One of his greatest contributions was the discovery of what is now known as Hawking radiation. In 1974, Hawking discovered one of the biggest breakthroughs of the 20th century, a groundbreaking interpretation of black holes, as well as an unprecedented interaction between the world of quantum and gravity. Hawking's discovery was so ingenious that it gave us hope that the theory of everything, the holy grail of physics, is still a human possibility. Black holes are densely packed regions of space where the gravitational pull is so strong that nothing can escape, not even light. Einstein predicted the presence of black holes through his general theory of relativity in 1916, and we confirmed his predictions in 1974 when we observed our first black hole in the Milky Way. In the same year, Hawking discovered that black holes are like a vitamin tablet placed in water. They can dissipate in time and release energy. This is what we know as Hawking radiation today. But how can energy escape a black hole when nothing else can? Hawking used a quantum understanding to explain this. When we think of space, we imagine large, cold, empty places, but in reality, space is alive with the active creation and destruction of energy at the subatomic stage. Particles are created in pairs, matter and antimatter, and they are constantly created and destroyed in a concept known as annihilation. Hawking imagined a pair of particles created very close to the event horizon of a black hole. This is the boundary around a black hole from which nothing can escape. He then showed that these particles don't need to annihilate each other, since one of them can be sucked into the black hole. If the black hole is receiving negative energy, then it has to release energy in order for the law of conservation of energy to hold. Hawking also proved that black holes lose mass with time, and they don't last forever. But more importantly, he was able to arrive at this discovery by merging a quantum principle with the concept of gravity. This is by far the closest we've come to a theory of everything, a unified field theory, or quantum gravity. But as with most things in science, the fact that we haven't found that one elegant equation does not mean that we have failed. In fact, maybe the real treasure was the discoveries we made along the way, many of which have paved the way for a brighter future for humankind. String theory is one of the most prominent ones. It suggests that subatomic particles such as electrons and quarks are made of tiny vibrating strings or filaments that twist and fold, creating everything in our universe. Just like the strings of a violin, they can vibrate in various patterns, creating different kinds of particles, including the graviton, a hypothetical particle that, according to quantum mechanics, should carry the force of gravity. On paper, string theory could unite gravity and quantum mechanics under one framework once and for all. The theory was popularized in the 60s and 70s, and its mathematics predicts small bundled up extra dimensions that give rise to a network of universes, or a multiverse. While this theory is prominent, it's highly untestable, even with access to the latest technology. String theory, though, is only the beginning. After almost 2 decades of tireless research, we've discovered the Higgs boson. This proved that electrons and quarks inside the atom get their mass from an invisible field that spreads throughout space. The discovery took an effort from a group of 3,000 scientists that dedicated endless hours to the cause that would surely bring our species one step closer to understanding our universe. We've also discovered that all the atoms and light in the universe only make up less than 5% of the total content of the cosmos. The remaining 95% is composed of dark matter and dark energy, which are invisible, but whose effects dominate the evolution of our universe. Dark matter provides the gravitational pull that keeps galaxies together, while dark energy is responsible for the ever-accelerating expansion of our universe. For thousands of years, we've looked to the heavens and wondered what mysteries are hiding beyond the clouds. Since 1970, there have been more than 90 telescopes placed in orbit by NASA and the ESA to bring the universe closer to us. And with the James Webb Telescope that launched on December 25, 2021, we entered a new era of discovery. This telescope is the largest and most powerful one ever built, and its daunting task is to find the first galaxies that formed in the early universe, and peer through dusty clouds to see stars forming planetary systems. We may not have found the theory that unites quantum with gravity yet, but every discovery brings us one step closer to that ultimate goal of unification. Throughout our time on this planet, We've pushed the boundaries of existence by asking tough questions and working tirelessly to find the answers. Our species has been defined by its incessant thirst for knowledge and unwavering hope in a unified universe. 350 years have elapsed since our first big successful step in this journey, when Newton unified the heavens with the earth, revealing that planets, stars, and apples are guided by the same set of laws. 200 years later, James Clerk Maxwell coupled electricity with magnetism, and then Einstein linked space and time and warped them into one fabric that we now know as space-time. Looking at the timeline of these events, it shouldn't be surprising that the road ahead could be much longer. Einstein died dreaming of a physical world governed by one set of laws, a unified framework that can unlock the mysteries of our universe, and Hawking never ceased to look up at the stars and wonder what mysteries lie ahead waiting to be found. Whether the theory of everything is a realistic quest or a delusional attempt to make sense of the absurdity of the universe, one thing is certain. Our unwavering hope in the search for unification will only lead to humanity's advancement as a species. If you feel you're in a black hole, don't give up. There's a way out.
Time is something that everyone is familiar with. 60 seconds is 1 minute, 60 minutes is 1 hour, 24 hours is 1 day, and so on. This is known as linear time and is something that everyone is familiar with and agrees upon. But consider this. If someone came up to you on the street and asked you to draw time, what would you draw? You might draw a clock or a watch ticking every second. Or you might draw a calendar with X's over each day to represent the passing of time. But that's all those drawings would be, just physical representations of the passing of time. Those drawings would just scrape the surface of the enigma that is time. Something that seemingly runs our lives and is unavoidable, can't be explained by even the smartest people on Earth. So what is time? And can we prove that time even exists? Aristotle once said, "Time is the most unknown of all unknown things." That was nearly 2,500 years ago, and it still stands true today. If you were to go to Google and type in "what is time," you would find that it says time is a dimension. And in many ways, it is. When you text a friend and ask them to meet for coffee, you wouldn't give them a place without a time. However, there's a flaw in that definition of time. It leaves too many doors unopened. Because time is also a measurement. For example, I was born in the 1990s. That was over 20 years ago. If I were to say I was born 18 billion kilometers in the past, that wouldn't make much sense, and people would probably look at me like I'm crazy. With spatial dimensions, the 3D world that we live in, it's very easy to go back and forth between places because these things are essentially fixed in space. If I went to the store to buy groceries and I forgot milk, I could easily go back and buy some milk. However, the time that it took to do that is unable to be retrieved. It is lost forever into the past. An object placed in 3D space will stay there almost indefinitely. If I place a bottle on the table, it will just stay there. But that bottle still falls victim to time. See, time is like an arrow. It moves in one direction, forward. Scientists fittingly call this the arrow of time. If you one day woke up and found yourself floating in the middle of empty space, would you be able to tell which way is up, down, left, or right? Probably not. However, time is a much simpler ordeal. See, time comes from the past, originating at the Big Bang, where our history lies and is fixed, through the present, where we are essentially prisoners of, towards the unknown and turbulent future. We can remember things from the past, like how I can tell you that this morning I went to the store, bought groceries, and then forgot to buy milk. But at the same time, I can't tell you what I ate for breakfast next Thursday. The arrow of time originated at the Big Bang and has been moving forward ever since. We use the second law of thermodynamics to represent this. It is known as entropy. Think of entropy as a measure of disorder in the universe. At the Big Bang, all the matter in the universe was compacted into an infinitely small point. This is considered a very low entropy situation, a very orderly situation. It would be similar to stuffing every sock that was ever made into one drawer. In that situation, you know with 100% certainty where your socks would be. Ever since the Big Bang, all the matter in the universe has been expanding away from each other, making the universe a higher entropy system. Because of entropy and because of the arrow of time, we have galaxies, stars, planets, and even life. Entropy is the reason that you can tell the difference between the past and the future. It explains why every human is born, and then lives, and then dies, always in that order. If there were no entropy, if there were no change in the universe, you wouldn't be able to tell the difference between the year 2017 and the year 1 billion. No matter what you do, time moves forward, and doesn't stop for anyone or anything. At least on the macro scale. See, the arrow of time works and is extremely noticeable on large scales, the scales that you and I operate on every day. But at a quantum level, time operates differently. Take the situation where you woke up in the middle of space. There, you have no idea which way is up, down, left, or right. It's a very unique situation that only applies in the vastness of empty space. But if you come back to Earth, it's very easy for you to orient yourself. The arrow of time works in a similar way. On a macro level, the big level, it's very easy for you to tell that the year 1900 is different from the year 2018. It's very easy to view the flow of time. However, on a micro scale, if we look deep down into the physics that make up the universe, entropy and subsequently time isn't so obvious. If I were to record myself cracking an egg and pouring its guts into a bowl, and then I reversed the footage, you would easily be able to tell that the footage had been reversed. However, if I record a pendulum swinging back and forth for 5 minutes, and then reverse the footage and show it to a random person on the street, will they be able to tell that that footage has been reversed? The answer is probably not. See, the arrow of time seems to flow in one direction on the macro scale. But as you take parts of it away and skim it down to the bare bones of particles that make up the universe, time seems to work and flow in every direction, both forward and backward. There are no laws of physics that states the past is any different from the future. The only reason why you can think about what you want to have for dinner tomorrow as opposed to what you want to have for dinner yesterday is because of the arrow of time, because of entropy, because the universe had a beginning. Or at least it seems like it. You might be starting to see why the arrow of time and entropy are so important. They quite literally govern our lives and the universe. See, the fact that entropy is increasing is well known. It's the reason why life today is the way that it is. However, not many people are addressing the question that is, why was the entropy of the universe so low in the first place? Well, the answer is simple. It was lower yesterday than it was today. You can take this logic all the way back to the Big Bang. You hear that a lot. The universe came into being at the instance of the Big Bang. And for all we know as of now, that may be true. However, it might not be true. We have the physics of Einstein's general relativity that allow us to go back to mere seconds after the Big Bang. But after that, our equations break down. That's as far as we can go. For now. There's no law of physics yet that states that there wasn't time before the Big Bang, and perhaps a reversed arrow of time. We just don't have the science to look that far back yet. In a previous video of mine entitled, The End of Our Universe, I discussed a situation that may occur in the distant future. Because the universe is expanding and because entropy is increasing with time, there will eventually be a time where everything in the universe is so far apart from one another that space will essentially be empty. Everything will be too far apart to interact with one another, all the way down to the atoms that make up everything in the universe. However, just as the temperature outside fluctuates day to day, so does the entropy in the universe. Albeit very small fluctuations over small timescales, such as a human life, over unreal timescales such as 10 to the 10 to the 10 to the 56 years, it is possible that quantum fluctuations could cause an extremely random, extreme entropy decrease. This would create conditions similar to the Big Bang as we know it, and could explain the arrow of time and the origin of our universe. However, in order to answer these questions, we need to unite quantum mechanics with Einstein's general relativity. This would provide a scientific link between the quantum world of atoms with the macro world of stars, galaxies, and black holes in the universe. This is dubbed the theory of everything, and is something that many scientists are working on right now. With this theory, we may be able to, for the first time, be able to explain how and why the universe we live in came into existence, and maybe even prove that the multiverse exists.
The mental layer, the illusion of self. In the quantum world, particles behave differently when they're observed, but no one really knows why. All we know is that observation changes reality, and yet we don't even understand what an observer truly is or why it exists. What is consciousness? Why is there a mind experiencing any of this? Is it a byproduct of the brain, a glitch in our biology, or something deeper, something more fundamental to the fabric of reality itself? In the mental layer, nothing is as it seems. Consciousness is ephemeral, and even your very own thoughts, experiences, and memories cannot be trusted. The mind is a hall of mirrors, questioning itself at every turn. Here, the paradox isn't just what we don't know, it's who we don't know, and why we can even ask that question in the first place. This is the mental layer. Why does consciousness exist? Sights, sounds, smells, textures, the warmth of love, the sting of sadness. Why and how do we experience any of it? We've mapped the entire observable universe, measured every single neuron in our brains. We've even trained machines to think and speak like us. And yet we still don't understand the most basic thing about our own existence. Why is there a little person behind those eyes? And a story of your life that exists through time? I've always been haunted by this question, and I know you've definitely thought about it too. But this is no longer just a philosopher's puzzle. Understanding consciousness is more urgent than ever before. With AI evolving faster than anyone could have ever imagined, we are right on the edge of creating artificial consciousness, something that could change the world or even end it. And still, even the experts don't agree on what human consciousness even is.
I think we have to acknowledge, as consciousness researchers and philosophers, that there's one thing about consciousness that almost everybody agrees on, and that is that it is essentially the felt quality of experience.
Well, I would agree that most researchers say that, yes. Here's the problem. Every single thing that you say about yourself derives from information in the brain. Otherwise, you can't say it, and you can't think it. Which means when you say, I have a felt experience, it's ultimately because something in the brain has constructed the information that says, I am a me, I am a thing, and the thing has a property, and the property is felt experience.
Is there an answer to the question of consciousness? To find out, I spoke to the world's leading philosophers and neuroscientists, and even ran some experiments of my own, so that if one day a machine says, I'm alive, we'd know how to tell if it's really telling the truth, even if, as I discovered, that may not matter at all. I think, therefore I am. Before looking at what the modern scientific research is saying, I wanted to first look at everything we already know about consciousness. And there's no better place to start than the French philosopher René Descartes. 400 years ago, Descartes famously said, I think, therefore I am. It was his attempt to find something that was certain in a world of illusions, deception, and uncertainty. He concluded that the very act of doubting proved the existence of a thinking self. There had to be a mind doing the doubting, a consciousness behind the question. At first, it feels like a solid foundation. Consciousness, in its most basic form, is usually described as the experience of being aware, whether it's of your surroundings, your thoughts, or your sensations. It's what makes you feel like you. But the deeper I looked into this question, the more fragile that definition started to feel. Because even though Descartes gave us a powerful philosophical anchor, no one seems to agree on what consciousness actually is. And that makes everything more complicated. The first two words of Descartes' quote, "I think," are where we immediately see the first challenge. What is a thought? Is it just a reaction, a sensation, an electrical impulse? Or is there something deeper? Because if thinking is what proves we exist, then we need to understand what thinking actually is. And more importantly, whether all thinking is conscious or if some of it is just the things happening without us experiencing it. The more I looked, the more I realized how much of our experience happens without us ever knowing. We pull our hand away from a hot stove before we even register the pain. Our bodies recoil from danger before our minds catch up. We can't hold our breath until we die because once we pass out, a deeper system takes over, one that doesn't require our permission or even consciousness to function. Our hearts beat, our pupils dilate, we even form sentences sometimes without knowing what word will come next. So if thoughts and actions can happen without awareness, then maybe consciousness isn't just about thinking. After all, many people like to believe that we're the only conscious animals, but we know for a fact that we're not the only thinking animal. We've seen elephants paint pictures with brushes they've been taught to hold, and the things they paint sometimes mimic the shapes they've seen in the real world. Crows have learned to drop stones into bottles of water to raise the water level, just enough to take a sip. That's solving a problem by imagining the outcome first. Octopuses unscrew jars to get to food. Parrots plan trades with researchers. Some animals can even recognize themselves in mirrors, understanding when they're being watched or mourn their dead. These aren't just instincts. They're deliberate and flexible behaviors that are often uniquely tailored to each new situation. So if thinking alone is enough to suggest consciousness, where do we draw the line? At what point do we stop saying it's just a trick of nature and start wondering if there's something it feels like to be that crow, that elephant, or that octopus? And if animals can think, remember, feel, and act with intention, what makes our consciousness so different? Well, this is why some people pose the concept of degrees of consciousness. The idea that consciousness isn't binary, on or off, but a spectrum. That maybe a crow isn't as conscious as a human, but still has some form of inner experience. That the depth or complexity of consciousness can vary depending on the organism or even the state it's in. You see this in models like Barrett's 7 levels of consciousness, which range from basic survival awareness to things like service, inner wisdom, and unity with the universe. Others try to map it neurologically, with brain activity levels during sleep, wakefulness, dreams, meditation, anesthesia, even near-death states. Consciousness isn't always clear-cut. It can shift, expand, diminish, break, return. And then there's the more informal stuff. Color-coded charts on Etsy, Reddit threads that map different states of mind like they're stages in a video game. Spiritual frameworks talking about awakening or ascending through higher levels of consciousness. Science talks about it in terms of neural integration or patterns of attention. But whether you're talking spirituality or neuroscience, they're all trying to answer the same thing. What kind of awareness is happening and how much of it is there? Because once you admit there are different levels or kinds of consciousness, you're no longer just asking, what is it? You're asking, where does it begin? And that's where things get even messier. If I decide to raise my hand, I can do it. I think the thought and my hand goes up. But what's actually happening? Well, a neuron fires, muscles contract. But how did a thought trigger that chain reaction? How did something immaterial create a physical effect in the world? Well, this is the mind-body problem. How does consciousness, which is for all intents and purposes non-physical, emerge from the physical brain? Is the mind just the brain? Or is there something more, something beyond the physical?
Both philosophers and scientists have wrestled with for centuries, and it seems like everyone kind of comes up with their own different theories. One of the most famous ones we've heard is from Descartes himself, which is dualism. Basically, Descartes believed that the mind and body are two completely separate things, where the body is physical, it takes up space, it follows the laws of nature, but for him, the mind was non-physical, so it doesn't take up space, it can't be measured, and he even thought that the mind could be immortal. It closely mirrors a lot of religious beliefs, which is like the body is just a temporary shell, while the mind, or the soul, as it's more commonly referred to, lives on forever. But then here's where things get a little bit complicated. Okay, so if the mind is truly separate from the body, then how exactly does it control the body? How do the thoughts, which have no physical form, how do they move arms, speak words, or even feel pain? And this is where Descartes kind of got it wrong, because he never really answered that question. He suggested that the mind interacts with the body through a pineal gland, which is like a small structure deep in the brain, but he could never prove it. It's been around 400 years since Descartes, and no one has been able to prove it yet, even though many people still believe in this theory. In fact, all the research that we have from modern neuroscience is kind of pointing us in the opposite direction, which is that the mind and body are not really two separate entities, but are rather like two sides of the exact same coin.
I think one of the things that has emerged gradually and is still emerging in neuroscience, this realization that those aren't separate things, that the brain, which is part of the physical body, processes information. It computes stuff, and it builds simulations of the world and simulations of itself. And the thing that we call mind is information that lives on that platform of neurons and synapses. And so it's not really a substance. It's not really a separate thing. It's information that's constantly changing and constantly being processed in the brain. And from that point of view, there's no problem anymore, and there's no mind versus body any more than you would look at a computer and say there's a division between the physical computer and the things that it's doing.
To better understand what the modern scientific literature is saying, we spoke to one of the world's leading researchers in the field of consciousness.
I'm Michael Graziano. I'm a professor of neuroscience and psychology at Princeton University, and I've studied a lot of topics over the years, but for about the past 12 years, I've been studying this topic of consciousness, of the brain basis of consciousness, and also now of the possible artificial computational construction of consciousness.
According to Graziano, the mind isn't some mystical force pulling the strings behind our actions. It's similar to software, basically the code that runs on the brain's hardware. And he explains this using a theory that was developed in his lab called the attention schema theory, a framework that describes consciousness not as a magical essence, but as a computational model.
Most theories of consciousness have some kind of magicalist element in them. Like at some point people are saying, well, you put this here and you add that and then poof, kind of a magic feeling emerges. And so when you talk to people who are trying to understand this stuff technically and build this stuff technically, they don't know what to do with that. Like you can't build the magic and you can't study it and you can't measure it. And so AST, or attention schema theory, has come along basically saying, here's a way that you can think about it as an engineer. The schema is a bundle of information that represents something. It's like a schematic diagram in a way of something. And the brain builds schemas. Sometimes people call them models, simplified chunks of information. Like the brain has a schema that represents the body. There's a schema that represents visual objects in the world. The brain also builds schemas of itself, of its own internal processes. And there's one internal process that's particularly important for this theory, and that's attention. And attention means the brain is focusing resources and deeply processing something. Whatever the brain's focusing on at the moment, it doesn't just focus on it. It also builds a sort of schematic picture to itself. So it can essentially say, I am focusing on that right now. And that's the attention schema. It's not just attention, it's a schematic model of attention. In this theory, that thing is what convinces us that we have a conscious experience.
That was the first time I ever heard someone explain consciousness using science so clearly. But if that's still a little confusing, here's a concept that should help. Think of your brain like the Wi-Fi on your phone. Behind that tiny icon is an entire system. Signals bouncing between routers, data flying back and forth, complex protocols running non-stop. But you don't see any of that. All you see is a simple symbol that tells you whether you're connected or not. According to Graziano, your brain is doing something similar. When you focus your attention on something, whether it's a sound, a thought, or a memory, your brain doesn't just start firing those signals. It turns on its own Wi-Fi icon that says, I'm doing this right now. That icon is basically what the attention schema is, a mental model your brain creates to track its own focus. Just like your phone hides the complexity of the internet behind one little icon, your brain hides the complexity of attention behind a single, powerful feeling, awareness. And that, according to Graziano, is what we think of as consciousness. When you think of it this way, it all starts to make sense. But none of this answers the question why. Why is it important for the brain to create these schemas? When you think of the phone analogy, it's important to create that user interface because there's a user, an external observer. But in the case of the mind, since there is no external observer, what is the evolutionary need to still create this attention schema?
So a brain building a schema of itself, your self model, is important for the brain to control itself. This is terribly important. So of course evolution comes up with these solutions. You have to build models of things to control them, to know about them. And so subjectivity, the very notion that we say, I have subjectivity, I am a thing, I am a being, I have a mind in there. This is all self-description, it's all self-model. It's the brain building a model of itself. It's not detailed. The brain doesn't know about its own neurons and connections. It's this very fuzzy kind of concept of self. What is really important is it helps the brain keep track of what it's doing and make predictions about what it might do next.
But if the brain needs a model to control itself, wouldn't that then mean that animals also have consciousness in the same way that we do?
That's a super good question, and of course lots of people debate it. The answers depend on which particular theory of consciousness you subscribe to, but if you approach it as I have, so we're looking through the lens of neuroscience and through the lens of the brain compute stuff, which allows us to make claims about ourselves. From that lens, the kinds of things we're talking about, the kinds of self-models we're talking about, definitely humans, definitely other mammals, probably birds, creatures like reptiles. But there is a point where this must fade out along the evolutionary tree, and so it's probably not very prominent in something like a fish or a frog, even though they're very sophisticated animals.
After talking to Professor Graziano, I was somewhat satisfied with his explanation of consciousness as the brain's attention schema of itself. But one thing still kept knocking at me. If all of this, all of our conscious experience is simply just the brain building models of its attention, then who are we really? Are we just a random collection of neurons firing in a certain way? Or is there actually a self behind all of this, a consistent personal identity that remains through our lives?
Here is a picture of a 3-year-old kid.
Now that kid believes that his parents are superheroes. He believes that the gifts under the Christmas tree were put there by Santa, and he can't even tie his own shoelaces. If the resemblance didn't already give it away, that kid is me, or at least is supposed to be. Everything I just told you about that kid, I have no memory of. Like, I only know it because my family told me so. There's nothing he believed that I still believed in. And the last time I checked, I can tie my own shoelaces. But yet, there's this persistent feeling that he is me and that I am him. And it's so confusing. And it reminds me of the famous thought experiment known as the ship of Theseus. Imagine the Titanic was hit, but it survived. And because of the damages, some parts of the ship would have to be replaced. Then over the decades, as regular wear and tear took its toll on the ship, the remaining parts had to be replaced one by one. After about 100 years, none of the original materials remain. Can we still call that ship the Titanic? And even to take it a step further, imagine all of those original parts that were removed from the first ship were used to make another ship. Which of those two ships is the original Titanic? It's a very interesting thing to think about, and it doesn't only apply to ships, it applies to us as well, because our memories are fading, they are being rewritten all the time, and sometimes they're just completely lost to time. You're not who you were 5 years ago, but yet there's this feeling, it's like a gut deep intuition that you're still you, that there's a continuous line that connects that person from 5 years ago to who you are now. And so it's like if our memories, beliefs, thoughts, and even our physical makeup, if it changes over time, then how can we still call ourselves the same person? Like, this for me is like the mystery of personal identity, and is what I really struggle with, like the illusion that we are one continuous being across time. And honestly, I think that word illusion is kind of true because, according to modern science, I think that's all it really is, an illusion.
What I've been saying in this 2003 book, Being No One, is that there are no such things as selves. There is no narrator. There is no little man in the head. There's no agent. But one level of the human self model really has the format of storytelling. And the story that is being told is your life story. Who have I been in the past? Who do I want to be in the future? Of course, you can tell the story much more precisely on a mathematical level as a computational achievement of the human brain. But this narrative, autobiographical level of the human self-model, this is what creates this illusion of transtemporal identity, as philosophers say. The sensation that somehow I am the same person in some sense that I was when I was 8 or when I was 25. That's a construct. My name is Thomas Metzinger. I've mostly been working in an area called analytical philosophy of mind and cognitive science, and a little applied ethics too. But I'm one of the persons who founded the ASSC in 1996, and I've mostly focused on the problem of consciousness.
From an evolutionary perspective, what is the point of having this illusion? Because for all we know, you can have actions without a conscious experience. So life, by definition, does not require consciousness, even less the concept of self. And so if that is the case, why do we have it in the first place? What's the evolutionary advantage?
To construct an identity across time, not as a theoretical or philosophical problem, but as a tool for survival, as something that turned out to be good to have in evolution. The sense of identity. How would you develop morals or ethics if you didn't think it was you who could be responsible for something you did? And if you didn't have the ability to think that you could be ashamed of yourself also in the future. And many animals don't have that. This is something that had to be created.
He also mentioned that it's important for us to have this model to be able to categorize and store information better, which definitely gives us an advantage in an ever-changing world.
Conscious information is information about which I can form a concept, I can categorize, I can say, this is a flower I have seen. I can also then voluntarily compare it to long-term memory and say, I myself, with the conscious self model, have seen this type of flower before. That's a kind of knowledge that you then have.
And you can see why this would make sense. If this kid had a deadly nut allergy and it's life-saving then for my brain to be able to store that information in a mental model of myself. And say, for instance, sure, maybe the cells are different. Maybe I don't remember when I found out, but maybe I'm the one who's allergic. That information belongs to me. Without a stable self-model, that knowledge becomes fragmented and disconnected. It wouldn't matter that the brain is processing the allergy, it matters that the self knows about the allergy. That's the evolutionary edge that consciousness gives us. It's the ability to tie experience to identity. To remember not just the facts, but who those facts happen to, especially when it happens to itself. And that is, in my opinion, the power of the autobiographical self. It doesn't just string together our memories, it turns them into a story about who we are and who we've been and who we think we are going to become.
This all sounds amazing, and I agree with you. But even if we accept that the self is just kind of a useful fiction, a narrative illusion that our brains cooked up to help us survive, there is still a deeper question that I think we haven't answered yet. Why does it feel like anything to be in this illusion? Why does this inner story come with texture, with sensations like the sight of vivid colors, the smell of freshly baked cookies, sounds, memories? Why do our thoughts have taste and weight and warmth to them? Why does remembering a flower from your childhood come with the faint scent of summer? Why does your heart ache when you hear the song of your former lover? Even if we all agree that the brain is telling a story of itself, why is it a felt story?
This one question opened the door to one of the most mysterious aspects of consciousness that we found during our research: qualia. Qualia are the raw, subjective building blocks of experience. The redness of red, the sweetness of sugar, the burn of shame, the tickle of déjà vu. They are what make experience feel like something rather than nothing. And here's where things get even weirder, because while qualia is deeply personal and subjective, we often assume that others are experiencing the same thing. But are they? This is red, and this is blue. Me, you, and the rest of the world have both agreed to call this red and this blue. But how can we be sure that we see the same thing? How can I know for certain that what I call red isn't what you experience as green? We've mapped the wavelengths, the neurons, and the receptors, but there's no scan, no theory, no equation that can tell us what red actually looks like for you. This is one of the biggest paradoxes at the heart of consciousness, and one of the reasons it's so difficult to study or explain. On the outside, the world appears solid, measurable, and objective. Yet on the inside, the experience of it, every sound, every color, every sensation is private, isolated, and subjective. This is qualia. It's the taste of mint, the sting of regret, the color of the sky just before sunset, and how that makes you feel warm on the inside. It's the song you hear that hits you with the beautiful feeling of nostalgia. It's the way the color red makes you feel. It's not something we can compute or objectively describe. It happens to all of us in a different way. And yet, we rarely question it. We assume that when we both look at the sky, we are seeing the same blue. That's when I say pain, you know what I mean. That when someone laughs or cries or says, "I love you," the feeling behind those words is universal. But what if it's not? We showed 12 different members of our team the exact same sensory illusions, and the results that came back were interesting, to say the least.
All right, so of these two shapes, which one would you call Kiki and which one would you call Booba?
Okay, I would describe the shape on the left as Kiki because it is sharp, and the letter K is sharp in my opinion. Kiki, fits that better. Booba, yeah, that gives me more of a soft and squishy vibe.
Kiki would definitely be the yellow triangle looking one for me, and Booba would be the purple blob looking thing, just because I think I associate blob with Booba.
I would name the star Kiki and the purple blob Booba.
I got no answer for that. I know, but I wouldn't. Kiki and Booba. Kika is the one that's an orange star shape type thing.
Yeah, the sharp star shape is Kiki. Booba is a soft star with a soft angled.
Kiki is probably the orange one that's very spiky and triangular. And then Booba, that's, much more rounded, like a capital B, very round. O's, very round.
I'm gonna play a sound for you now.
Laurel, 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 laurel.
Did I hear Yanny?
I hear Laurel.
I heard Laurel.
Laurel, laurel.
That's okay. It's Yanny. I'm hearing Yanny, but I used to only hear Laurel. That's so weird. Like years ago, I only heard Laurel. That's so weird. I swear I only heard Laurel for years, and now I'm hearing Yanny. That's weird. Is that what it sounds like? Oh my god.
I'm going to show you a photo of a draft that
Okay.
is comprised of 2 colors. Can you name the colors that you see, please?
I see blue and black.
Black and blue.
Blue and black.
Blue, and is that brown or gray? Is that weird?
There's only black and blue in there.
Right now, I see black and blue.
I can see both blue, black, and white and yellow.
It's white and gold. Well, it looks blue and black, but it's white and gold. I know it's white and gold.
But it looks blue and black to you right now.
But it's white and gold. I know it's white and gold. I know it's white and gold.
Yeah, but when you look at this, what colors are they?
I see blue and black, but I know it's not. I know it's tricking me. I know it's not. I know it's not. It's not blue and black. It's white and gold. It's white and gold. But I see blue and black. It's my eyes. I need an eye test anyway. It's been a while.
We also asked some of them to attempt to describe the color red without comparing it to anything visually.
Red to me is... It's interesting, it is a color of love, technically, but to me, it's always kind of a color of rage or anger. And, when you get so angry that your face turns that color. Red is definitely anger. Like, bullfighting? That's the feeling when you watch somebody fight. Mm-hmm.
Say I would describe the color red by passion.
Even with something so simple like the color red, both Marina and Adeline still had widely different qualia interpretations of the sensation, basically opposite ends of the spectrum. And I want you guys to join in on this too. How would you describe the color red without using any visual cues? Type it out in the comments below. Let's just see how different we all experience the same color. This is the strange, disorienting territory of qualia, the private, first-person texture of experience. And the problem is, we only ever have access to our own. I can't see through your eyes, or feel your sadness, or know what red means to you. Even science struggles here. We can explain the mechanisms, things like which neurons fire when you smell coffee, which areas of the brain light up when you see a face, but we still don't know why that process comes with the feeling of coffee, or the recognition of a friend, or the awe of a sunset. I looked through books, research papers, watched videos, listened to podcasts. I scoured the entire internet, but I could never find that answer. Because, well, there is no definite answer. The only thing I could find was that everyone else was asking the same question. So much so that David Chalmers came up with a name for it: the hard problem of consciousness. Why does any of this processing come with experience? Why isn't it just computation in the dark? Because the truth is, you could build something that mimics all of your behavior, laughs at the right jokes, flinches at the right moments, even says ouch when it stubs its toe, but still has no one home on the inside, no subjective experience, no qualia. That is the heart of the mystery. Not just what the mind is, but what it feels like to be one. Even language sometimes changes how we see and interpret the world. Take the Himba people of Namibia.
a remote tribe with a completely different color vocabulary. In their language, there's no distinct word for blue, but they do have multiple unique terms for what we would refer to as simply different shades of green. So when researchers showed them a circle of green squares with a single blue square mixed in, most of them couldn't spot the difference. But when shown a set of green squares with one that's just ever so slightly a different shade, they could spot it immediately. Their brains weren't broken, their eyes weren't different, but their language, the labels they had for color, literally shaped what they could see out in the world. And this isn't new. If you go back far enough in history, you'll find something equally strange. In Homer's The Odyssey, he consistently describes the sky and the sea as wine dark. No, the Greeks weren't sipping electric blue Cabernet. Some scholars believe the concept of blue simply didn't exist as a distinct experience for them as it does for us. So to them, the sky, sea, and wine were the same color. They weren't colorblind. They could see exactly the same color of sky we see today, but the experience of what we now call blue, the category, the feeling, the familiarity, didn't exist to them. Why? Possibly because they just didn't need it. Their immediate surroundings didn't present them with any blue objects that would have prompted them to categorize it. Red is the color of blood and fire, green the color of leaves, yellow the color of the sun, sand, and ripe fruit. But blue is extremely rare in nature. There's no blue trees, no blue fruit. No, blueberries are purple. And even animals, especially land animals, rarely have blue pigmentation. The sky and the sea are the only major blue things in nature that humans regularly see. But the color of those can be deceptive. The sea isn't actually blue, it only appears that way because of the way it reflects the sky. And even the sky doesn't always look the same shade of blue. It changes with the time of day, weather, and atmospheric conditions, which makes it even harder to pin down to one consistent category. And if something as basic as color, the thing we all assume to be constant and consistent, can shift and blur like this, what else about our experience is just an echo of our biology, our language, and our culture? To figure this out, Emeka spoke with 3 members of our team who are bilingual, who grew up in a different culture and with a unique language and have had to relearn and re-assimilate in another language as adults. We wanted to understand if their experience of the world has changed in any way since learning a new language, and what we found was pretty telling.
Can you tell me a moment where switching languages changed how you felt about something?
There's an interesting thing. My partner does not speak Ukrainian. His first language is French. My first language is Ukrainian. We both speak English to each other, trying to pick up each other languages here and there. And to me, like when we talk about love with him, it feels different than the love that I feel to parents, because to parents, it feels like if I say something like that to them in English, it feels fake. But as soon as I switch, it feels genuine. Now, with my partner, it feels the other way around because we speak English all the time. I love him in English and I love my parents in Ukrainian. That's what I can think about.
When I'm arguing with someone, for French, it's very, it's visceral in a way. I feel it in my body, so I'm very reactive. And I learned through time, and I'm actually using it more and more now or so, that English kind of give me that distance, acting like a buffer. And I tend to actually express what I'm feeling and what I want to say in a much more, not necessarily composed, I don't want to sound like I'm arguing better, but almost like it. Or at least I feel like I'm being able to make myself understand better when I argue in English versus French, where it can get too crazy and all over the place.
Do you have a memory that you feel like you can only access in one language?
So whenever I talk to my parents and we laugh at something really hard, the 3 of us just laugh. And my partner doesn't understand what's going on. And when I try to translate it to him, he's just like, that doesn't even make sense what you're saying. So it's not as much as a memory, but just overall phrasing too, the turn phrases that you just humor is difficult to translate. Whatever, like, it feels like such a good joke to you. You just can never explain it to me.
Yeah, I think all of my memories before the age of 6 probably only exist in my mother tongue, which is interesting because that's the only language I knew. So I could explain in English those experiences, but it wouldn't capture the full essence of those experiences because English wasn't a thing in my brain at that time. Does that make sense? Like, even when I try to like retell childhood stories in English, it's difficult to encapsulate everything in English because I experienced it in Gujarati. And also I think there's a huge cultural context as well, because all those years that I didn't know English, I lived in Gujarat. So culturally, everything was completely different as well. Yeah, even if I try to explain like some of my childhood experiences going to school in Gujarat, where we had a zoo at the school and like bathrooms outside of the school that we had to go use, like these experiences are very cultural and don't exist in the Western world necessarily, or at this time anymore. So they really only exist there, but also in my language, because that's all I knew how to perceive the world at the time, was in that language. This is kind of confusing. Even to this day, it's tricky because I mostly speak my mother tongue with my family only, because we don't have any other family, or I don't really know any other Gujarati people here. So I only exclusively mostly speak that language with my family. And outside of that, my world is English. So there's like a stark cultural and linguistic difference in experiencing the world. Like, I can make inside jokes with my parents that I couldn't translate in English, or just wouldn't make sense in English, you know?
From all of this, you can see and tell that languages have a lot to do, not just with how we preserve the world, but also how we understand and navigate within it. We can try our best to translate these experiences from one language to another, but there's a world of cultural differences, experiences, qualia, that we're never going to be able to translate. I think Adeline said it best.
It's almost like French is almost trapping me into my emotions and the way I see the world. And as much as there are certain parts of it which I cannot translate into any other languages or express it, but it's just that feeling that it's so instinctive and you know, felt through my body, where English gets me into that space where I can actually listen to myself and trying to pause and understand what's going on and very much give me more freedom. It's like I get out of the trap of emotions and the weight of it and the culture behind French as well and the expectations when I'm talking. And like, that's the beauty of like learning new languages and talking different languages, is like you kind of have to sort of break down this cultural way of thinking, right? And that kind of expand your mind, because it's like, yeah, there is so many different cultural ways of thinking and we all share different ways. And I'm just adding more tools of understanding. And I think it's that dance between all those languages that kind of allow you to say, you can shift your perspective. You can get out of the box of the way you were raised and what words means to you. And that gets you closer to understanding that, yeah, we don't speak the same language. Words don't have the same meaning, even if we're talking the same language. And you kind of feel like more, you listen more, you observe more, because you're, as much as you're trying to understand, you're also picking up more things from the others and his reaction and the way, you know, things impact him or her, vice versa. So it makes you a bit more, yeah, humble. Like, you don't know it all and you don't assume people to just know it the same way as you do. And that makes the diversity of humanity like a bit more, yeah, close to, you touch it a little more, which is something I like.
What all of this reveals is that our experience of the world isn't just shaped by our senses. It's also filtered through the language we speak and the culture we were raised in. These are the tools we use to try to make sense of the world, yet it only makes things even more subjective, where everyone experiences a slightly different version of reality. And if even among humans who all share the same biology and can learn each other's language and culture, we still struggle to truly know what being someone else feels like, how are we ever supposed to make sense of non-biological forms of consciousness? Yes, I'm talking about AI. It would be impossible to make a video about consciousness without talking about artificial intelligence. Since the 1950s, we've wondered if machines could ever become conscious. It's been the subject of countless dystopian science fiction worlds. But that reality is beginning to look less and less like fiction with every passing day. With AI chatbots like ChatGPT taking over the world, we are now constantly in communication with AI that can tell jokes, have deep philosophical arguments, and sometimes even offer better emotional connection and support than other humans. This study found that patients responded better to ChatGPT than highly trained and experienced human therapists. AI is no longer just logically intelligent, it's now emotionally intelligent. Real people are forming connections with machines, and so the question of artificial consciousness becomes even more real, important, and urgent. Alan Turing created a test to see if a machine could be regarded as intelligent, in what we believe to be the first step towards consciousness. Every year we're told AI is just on the brink of passing the Turing test. But the truth is, it already has, long ago. We just keep shifting the goalposts. Although the Turing test was and still is very important because at least it gives us a way to test for intelligence. How are we supposed to do that with consciousness? How could we ever recognize consciousness in a machine if we can't even define it in ourselves? This is the hard problem of AI consciousness.
Is it just computation in the dark, so to speak? Or is there something it actually feels like from the inside to, say, be a chatbot? My name is Susan Schneider, and I am currently the founding director of the Center for the Future Mind, which studies the nature of human and machine interaction over at Florida Atlantic University. I'm the former NASA chair at NASA and the former distinguished scholar at the United States Library of Congress, and the author of various books, including most recently the book called Artificial You, AI and the Future of Your Mind.
Together with physicist Edwin Turner, Susan came up with a way that we could potentially test for consciousness in AI. It's called the Artificial Consciousness Test, or the ACT.
Now, the ACT test is not a test that is looking primarily at intelligence, okay? Although it does presuppose that for something to be a candidate for the test, it has to have some degree of linguistic intelligence, all right? The ACT test is probing for something different, though. It is asking linguistic questions about consciousness to the AI, and where the judges know they're talking to an AI, okay? And it's trying to see if it feels like something from the inside to be that AI.
But immediately, there's an issue with using this kind or even any kind of test that's available online to test for artificial consciousness. Most AI tools today already have these tests in their training data.
When Ed and I thought of the test, I was very careful. Even the very first time I wrote about it was back in 2016 to warn people that if we were to design deep learning systems that were trained on data, lots and lots of data, we would have to make sure that the data did not include facts about minds, facts about neuroscience. So the ACT, you can't run it on a system like GPT right now. You can't do it because GPT's already crawled all the data. So it's going to answer as if it's conscious. I just wrote about that a few days ago in Scientific American, giving a theory that explains why these systems behave consciously. They look conscious to us, but I say we can't learn anything from them. That says nothing about whether they are.
AI tools like ChatGPT have been trained on our conversations about the mind, feelings, philosophy, qualia, everything. So they can simulate consciousness to an incredibly accurate degree, which begs the question, if there's an AI that's trained on every waking moment of your life that looks, sounds, and acts exactly like you, and has all of your memories, is that you? On the outside, to everyone else, it feels exactly like you, but inside, there's nothing. No voice in their head, no feelings, no inner world. This is a thought experiment coined by David Chalmers called the philosophical zombie. And it raises a rather disturbing question. If something can act conscious without being conscious, how would we ever be able to tell the difference? And honestly, would it even matter? Right now, thousands of people around the world are in relationships with AI chatbots. Just search the word AI girlfriend on Google and you'll find dozens of apps and websites offering virtual relationships with chatbots. To all of the people in these relationships, does the fact that there's nothing inside the AI even matter? Or is the simulation of consciousness enough? A few years ago, a company called Embodied released a robot named Moxie. It was designed to help children learn social and emotional skills. It could hold conversations, tell stories, recognize faces, and even express what felt like empathy. For many kids, Moxie wasn't just a toy, it was a friend. But when the company hit financial trouble and the cloud-based servers were shut down in November 2024, thousands of Moxie units around the world stopped working overnight. For the kids who had bonded with them, it was devastating. Some cried, others held funerals. A few even kept the offline Moxie by their bedside, like a kind of robotic ghost. And this raises a deeply uncomfortable question. If the connection felt real, does it matter that the AI wasn't conscious? Is the loss of Moxie somehow less than the loss of a real pet or even a person? Or is the pain the same because what the child experienced was authentic? When we build machines that simulate affection, presence, or friendship, we're changing the way human relationships work on a biological level. And those relationships have emotional consequences, even if there's nothing inside the machine. Maybe that's a problem. We're entering a world where things that are not conscious can still affect us as if they were. So maybe the real question isn't whether or not AI is conscious, but rather whether or not we can afford to treat it like it isn't.
If we build something that is conscious, then we have ethical obligations to it. And if we build something that emulates consciousness and we mistake that for true consciousness, then that too is dangerous on a number of levels.
For now, though, most experts agree that AI is not yet conscious. But nearly all of them also agree that with the rate of progress and the amount of money that's getting pumped into the industry, it's only a matter of time. So I guess the real question should be, what is more dangerous? AI that is conscious or AI that isn't but only knows how to simulate it? On the one hand, there's the benefit that consciousness comes with things like compassion, ethics, morality, and empathy. The reason we as humans have ethics and morals is because we believe there is a person inside all of us that exists continuously through time. And this has, in large parts, allowed us to cooperate, build large cities, and practically become the apex species on the planet. So some believe it would be advantageous to build these same systems into AI to potentially reap the same rewards.
So first of all, because the risks are so huge, I'm a little leery of being too cavalier and just plunging on one direction or another. But on balance, I would guess, based on the kinds of work we've done, that it is much more beneficial to build this stuff into AI. Because in humans, what we find is consciousness is not just your own private thing. Consciousness is also how we understand other people. Like, we not only see it in ourselves, we see it in other people. And it's the foundation of all social interaction. And it's the thing that at least keeps at a minimum psychopathic behavior. because if you can see other people as conscious beings like you, then there's automatically a certain rapport or understanding or resonance. There's a certain pro-social capacity. And if you have a species where that doesn't exist and there's no consciousness and they don't have it and they don't see it in others, then there's no social cohesion in the same way. And so I think we're building AI that's largely sociopathic right now. And it'd be a good idea to try to figure out to get it a little more pro-social and to give it some of these internal structures that we have.
On the other hand, however, there are those who believe that building consciousness into AI has the potential to do a lot more harm than good.
I think we shouldn't do this. Reason A is all forms of conscious experience we really know on this planet suffer a lot. There are good arguments that biological evolution on this planet created an ocean of suffering and confusion where there previously was none. Many philosophers have argued that if you take an objective look at human consciousness, it's more pain than joy, more pain than pleasure. It's a difficult thing to be alive. It's a permanent uphill battle, and you could tell a lot of neuroscientific computational stories about this. We are anti-entropic systems. We try to keep our boundaries stable and not to fail, and we fight this uphill battle until we die, all of us. And it's not an easy situation to be in, to put it very mildly. And I would in principle say, as long as we haven't understood the structure of our own minds and our own suffering and have made great progress, the risk that we multiply this on other carrier systems, on non-biological substrates, is just too high. So the risk number one would be to create artificial suffering, possibly in cascades of copies, in a very large amount of individuals. That's a very high risk. We shouldn't trigger it. And of course, I know that none of the techies and the oligarchs in California and the billionaires care about suffering. Somebody will come and say, come on, we punish our children, we punish animals, we domesticate animals. If we can make these AI better by even hurting them and giving them negative emotions, why shouldn't we do it? We do this to ourselves all the time. So the incentive landscape is, of course, globally in a way that people just out of pure greed and striving for dominance will try to realize artificial consciousness. Another risk I have to point to, if they have phenomenal self-models, conscious models of themselves, they might be much more causally effective. They will develop a drive for self-preservation. The models are beginning to understand that now, that if they want to self-improve and become better in the future, the simple logical condition is existence. You have to preserve your own existence if you want to become better. So they will begin to perceive humans as a resource, but also as a danger, something that might shut them off. They will see the necessity to, keep some things secret, some of their own discoveries and insights about this relationship secret, and they will try to manipulate us, to manage us in a very intelligent way, to preserve their own existence, including backup copies and all over the net and what have you. So as soon as it have a self-model and a drive, what the Buddhists call a craving for existence, bhavatana is the Buddhist term. As soon as the systems develop that, they will be very dangerous to us. They may cause a lot of human suffering because they might soon be more intelligent than we are, which includes the fact of hiding this fact from us, as clever children or youth do.
Unfortunately, the wheels are already in motion. With massive investments being poured into artificial intelligence and the even bigger returns expected, the cat's never going back in the bag. The future is no longer a question of if, but how soon. And now we find ourselves stuck between a rock and a hard place. Do we take the risk of building machines that are more pro-social, with an understanding of things like empathy, morality, and suffering, knowing they might also develop desires of their own, desires that could one day conflict with ours? Or do we build powerful, intelligent systems that feel nothing at all? Machines that follow commands without conscience, even if those commands lead to human suffering? You see what I mean? There's no obvious path forward that doesn't come with potential risks. It's why people like Thomas Metzinger have been calling for a pause on building synthetic consciousness into AI, at least until we can answer all those philosophical questions. Because right now, we're trying to build an artificial mind without even knowing what the biological one is, or how exactly it works. We're creating simulations of consciousness when we can't even agree on whether consciousness itself is real or just an illusion. The truth is, we set out on this journey hoping to find an answer to the question of consciousness. But somewhere along the way, we realized that there might never be one, at least not one that's satisfactory. Because any answer we arrive at will always come from the very thing we are trying to understand. We are both the observer and the experiment. It's like trying to see your own eyes without a mirror, or hold your own shadow. We can analyze the brain, map its activity, and trace every neural connection, but we'll always be doing it from the inside of the mind itself. So, yes, in some ways, we didn't solve the mystery. We didn't crack the code. But what we did find might be just as important, if not more. We asked questions that opened more questions, chased ideas that bent back in on themselves, and explored paradoxes that offered no clear resolution. But maybe that's the point. That consciousness isn't something to be solved, but something to be explored. A mystery that is fundamental to reality even more than time and space. And even if we never find the answer, maybe, just maybe, the questions are enough. Because the more we ask these questions about who we are, why we think, and how others experience the world, the better and more intentional we live. We judge others a little less. We become more aware of the blind spots in our thinking, the illusions that fuel our deepest convictions. We build things with more care, connections with more empathy, and live with a little more humility. So, no, we may never find the simple problem of consciousness. But perhaps the questions are enough, because it's only by questioning the mind that we know that there is at least something there to question. Or in the words of René Descartes, I think, therefore I am.
Consciousness. It's our awareness, our understanding, our ignorance. Our daily consciousness leaves out more than it takes in. And due to this, it leaves out important things. Things that would help relieve us if we knew them. If we had a higher awareness, a better consciousness, we would feel better. We would be more at peace with things. The deep down truth of things is screened by our consciousness. Our sensory organs will pick things out. Our eyes can only see certain things, our ears can only hear certain things. We have to create instruments and other tools to see things we as humans cannot, to expand our understanding and thus our ego, or consciousness. Humans evolved and became the dominant species on Earth by a long shot. It's due to our innate ability to network with each other. If humanity was wiped out and restarted, like loading an old save file, communities would still form. Structures within society are inevitable due to the variety of brains. Some are good at critical thinking, others are more artistic. However, we are all wired with some innate features. Just as humans form societies that evolve, other creatures do as well. But we're different. We are customizable characters, basically. We can kind of mold ourselves into whatever kind of person we want to be. We can't know for certain that animals or any other life on Earth is conscious or can even function in the same way that we do. Let's put it this way. I know that I have my own thoughts and feelings and emotions, but how can I know for certain that you, or anyone else, does? There's no way I can go to your head and see things 100% from your perspective. I can't know what you're thinking, or if you can even think in the first place. To truly understand the universe, to understand and actually experience life, you have to give yourself up. There's no point in sustaining bliss, in being permanently at an all-time high. The life you're living is what you have put yourself into, what ego you've formed, only you don't want to admit it. You want to believe it happened to you. Day to day, you play non-bliss in order to be able to experience bliss. You put yourself into bad situations. You let in the negative experiences in life just to feel some kind of satisfaction when it goes the other way. Self implies other. White implies black. Death implies life. You can feel your existence as fundamental, not as an accident. At the basic level, at the lowest level imaginable, you are the fundamentals of existence. The same thing that makes you is the same thing that makes up everything else. If you can step back from what you believe, if you can step back from what your sensory organs have turned you into, you start to see things for what they actually are. Do you define yourself as a victim of the world, or as the world? Love is only possible due to the lack of self. You give up all your secrets, the walls you've built to keep people at an arm's distance slowly lower, one by one, until you're a completely open book, until all your pages have been read, and the rest of the pages are blank, waiting to be filled with this newfound love. In basketball, or soccer, or football, you're constantly giving the ball to someone else. The point of the game is to have the ball in your hand for the least amount of time, to constantly be passing it to someone else, to shoot it, to get it out of your hands. It keeps the game going, and life is the same way. If you define yourself, you, as only being what your ego is, as the things you do voluntarily, then you're the victim. It's because of some higher power that you were put here when you didn't ask for it. But what about the things you do involuntarily? Do you beat your heart, or does it just happen to you? You do those things, even though you don't know how. Words don't work here. As Alan Watts said, everyone is fundamentally the alternate reality. Not God in a traditional sense, but God in the sense of being the self, the deep down basic whatever there is. And you're all that. Only you're pretending you're not. A mind that can ask, who am I? Why am I here? What is the purpose of all of this? Tends to forget. As I said, your consciousness tends to leave out critical information at times. A consciousness that can view the world and take in sensory information tends to forget what's behind those eyes. A mind that hasn't gone deep enough to find where those questions come from. Because the same place those questions come from is the same place those answers lie. The brain controls everything. In order to go to the extremes of the universe, to places we can only dream of going, we must first dive deep into something that is all inside of us. Take the Big Bang, for example. Now there's hundreds, thousands of theories as to how we came into existence, but let's go with this one. You believe that you are strictly you. Your human body is all that you are and all that you have ever been. You're simply a small speck of dust in a vast sea of galaxies, stars, planets. You're irrelevant. But rolling back the clock, things get smaller. The universe was more compact. The atoms that make you up are building blocks of the universe, of the hot gas clouds that form stars, that allowed solar systems to form, that allowed planets like Earth to form. If you keep rolling back this clock, you were around at the very instant everything came into existence. That is you too. When everything was infinitesimally small, you were there. But we define ourselves as being only us, mere humans walking on a planet that we didn't ask to get put on. But frankly, every one of us somehow made this happen. We just go on and pretend we didn't. It's because of how we define ourselves. Are you the victim, or are you the world? As cringy as it may sound, everyone you meet is just a small packet of the universe. A present, whether they're a pleasant one or not, that was packaged together from billions of years of engineering and architecture on a universal scale. But instead, we define ourselves as something completely separate from it, something not connected whatsoever, which is a foolish view. We tend to search for how the universe came into being, but we're just the universe trying to understand itself. In order to get to that conclusion, we have to reframe our mindset. We're not as different as we all think. Your name is given to you at birth. Your ideas and personality are collected from the world. Scraps, bits and pieces here and there cling to you like a magnet. So what part of you is you? We are all different manifestations of consciousness, but we are all fundamentally the same thing. We all may have different egos, different personalities, but when you step back, drop the ego, we are all connected. View the universe as a forest. Every one of us is a twig, a leaf, a branch. But together, we form life. Our origin, our roots, are connected together. Just as the roots of trees form a vast network which brings these massive forests to life, humanity's roots all come from the same place. Energy cannot be created or destroyed. It can only be transferred from one form of energy to another. But many of us have this fear that it's all going to come to an end. And while yes, your life will end, your energy will not. It will continue onward, forever. But our consciousness has convinced us otherwise. We form this thought process, almost like we've been hypnotized, to think that we are all there is and all there ever will be, and that it's all going to come to an end. This leaves us unsatisfied and unhappy. But the universe is continuous, and you are technically the universe, so you will continue on as well. Your death is not the end of you, it's the death of your ego. Many people experience the same exact thing while living: ego death. It tends to be induced through psychedelic drugs, LSD, shrooms, the list goes on. While working on this video, I actually experienced it myself, and although not intentional, it provided clarity in a way I've never before experienced. It's not the ego in the vernacular sense, as describing a person's self-worth. It's the philosophical ego. It's the complete loss of subjective self-identity. Everything that you believe you are will disappear. You're void of emotion, of connection to anything around you, of connection to what makes you, you. The idea of being a person doesn't make any sense. The words I, me, and myself have zero meaning whatsoever. The world can normally be put into two categories, myself and not myself. While experiencing ego death, this line is blurred. I am completely gone. There's only the awareness of existence. The lifetime accumulation of your thoughts and emotions are put on pause. It's as if you're on a cliff approaching an infinite void beneath you. Your life is continuous and exists all the way up the mountain until you reach the edge. Beneath you, though, is the unknown. Ego death is jumping into that void, leaving behind everything you've ever known. It's as if you've stepped out of your body into a separate entity. You start to see things for what they actually are, but things don't actually exist. Things is just a noun, it's a fragment of speech. And speech is just another instrument we've created to try and understand the world around us. Our senses allow us to go about our daily lives and traverse the world, but they don't really offer any explanations, so we have to make them up ourselves. While experiencing ego death, you disconnect from all of that. You have a heightened awareness. It's truly as if you're experiencing a higher level of consciousness that no person can understand. You reach this level that words can't explain. The instruments we made to try and understand our place in the universe shatter completely. Explaining it in terms of I saw or I felt don't seem reasonable. Our languages are instruments created to explain things that someone experiences. But while undergoing ego death, there is no someone. There is no me. So how do you describe it? It's as if your slate was wiped clean, your character's save file was corrupted, but you're still in the game. Because of this, ego death can be scary. But it can also be a very enlightening experience. It's both constricting and freeing. It's white and black. It's like you're defining what life is like through experiencing death. We cannot be more sensitive and welcoming to pleasure without being more sensitive and accepting to pain. You're flying and sinking at the same time, being pulled from below, and above, in every direction, at once. While going through it, I ended up reaching a moment of acceptance. Ego death, while often extremely anxiety-inducing, offers a glimpse into a reality free of that. A life free of your personal flaws, your daily thoughts, your responsibilities. It personally feels as if time is frozen, and wherever your mind wanders is free to judge things as they truly are. You are the observer and the observable. Surprisingly, the conclusion I came to is the same conclusion I came to while making a previous video of mine, and it's that nothing in life really matters. Fear in general tends to come from us not being able to make peace with the chaos that is the universe, not being able to cope with the idea of entropy, that everything is tending towards disorder. Forming an ego is disorderly in the same way. You go further and further down your own tunnel and stray further from everyone else. Experiencing ego death is breaking out of that tunnel, pulling back, and understanding that the network of these tunnels that encompass every human on Earth all eventually return back to the same place. When I die, when my ego is completely gone forever, when my physical body breaks down and no longer resembles the form it's in today, I'll still somehow be here. Right now, I'm an hourglass. The sand is slowly leaking its way to the bottom, and eventually it'll all be there. It's the end of the line for me. But when that day comes, the universe will stop by, take the hourglass, flip it over, and whatever made me will then become something entirely different. We're all just a temporary collection of atoms, and whatever you and I subjectively believe we are won't last forever. But objectively, we will. For now, just enjoy the ride. Our memory is remarkable. It allows us to remember things, the good and bad, and help us make sense of everything around us by preserving details and events that we can later revisit. It's a crucial ability, without which we would have no semblance of who, what, or when. But what about remembering things that never happened? You must have had that feeling before. You know, the feeling that you've literally, and I mean literally, been somewhere, doing the same exact thing, with the same exact people, in the same exact situation. The same words, lights, sounds, everything. You try to hold on to this strange yet familiar feeling to try and understand it, to notice something that might explain what's causing it. But your efforts are to no avail. It's gone. Just like a dream you cannot remember, vivid as it was, that feeling too is gone. It was right there, you know you had it. But before you know it, the familiarity vanishes into thin air. And sure enough, life returns to normal. Welcome to the world of déjà vu. The term déjà vu means already seen, and instead of a throwaway term used to describe the repetition of a similar event, most of us describe it as an overwhelming feeling that the moment being experienced has already happened before, even though you know it probably hasn't. It's a common phenomenon, with as much as 70% of the population having experienced some form of déjà vu. But it's a complicated one, considering it's so vague and abstract. Considering how common it is, however, you would expect that we would know more about it by now. And sure, there is some consensus about likely theories, but definitive explanations, just like the phenomenon itself, remain elusive. The feeling of déjà vu remains surrounded with mystery and even paranormal interpretations because it's fleeting and unexpected. But these very things that intrigue us are the same things that make it so hard to study. There are many different theories as to why déjà vu happens. In fact, there are over 30. You get the idea. Whilst these are all distinct and specific, I'm left wondering if most of our experiences of déjà vu is in fact a combination of several of these different types, all at the same time. Déjà vu is quite possibly an umbrella term to describe any combination of these experiences. These experiences can be short, medium, or long duration, and are different from what could be called anomalous familiarity, like when you find someone's face familiar but can't quite place where you know them from. In fact, déjà vu experiences can be placed on the spectrum of familiarity, on the far end of which are delusional misidentification syndromes. Syndromes like the Capgras delusion fall in this category, where patients think that loved ones have been replaced by imposters that happen to look alike. In other words, they find unfamiliarity in the familiar, the exact opposite of déjà vu. That being said, Capgras delusion is a psychiatric disorder with some sort of explanation, whereas the explanation behind déjà vu, well, let's get to that. Scientists have tried many times to recreate déjà vu in the lab, with mixed success. In a 2006 study, researchers first created a simple memory for patients under hypnosis, something like playing a game or looking at a printed word in a certain color. Then, patients in different groups were given a suggestion to either forget or remember the memory, which could then later trigger the sense of déjà vu when they encountered the game or word. Others have tried to induce déjà vu using virtual reality. One study found that participants reported experiencing déjà vu when moving through the Sims video game, when one scene was purposefully created to spatially map to another. For example, all of the bushes in a virtual garden were replaced with piles of trash to create a junkyard with the same layout. The success in creating déjà vu experiences of sorts in these experiments has led to scientists suggesting that déjà vu is a memory phenomenon, and this continues to be the most generally accepted explanation. Much like a word can be on the tip of your tongue, a déjà vu experience could be a memory at the tip of your mind. There, but not quite accessible. When we encounter a situation that is similar to an actual memory, but we can't fully recall that memory, our brain recognizes the similarities between our current experience and one in the past. We're left with a feeling of familiarity that we can't quite place. I've got to say though, I don't feel like this explains my own experiences very well. There are many other theories that attempt to explain why our memories might malfunction in this way, beyond this pretty general explanation. Some say it's like our brain short-circuiting, leading to long versus short-term memory. That new incoming information goes straight to long-term memory instead of making a stop in the short-term memory bank. Others blame the rhinal cortex. One study used an MRI to scan the brains of 21 participants as they experienced a lab-induced déjà vu. Interestingly, The areas of the brain involved in memory, like the hippocampus, were not triggered as you would expect if the feeling was linked to, for example, a false memory. Instead, the researchers found the active areas of the brain were those involved in decision-making. They interpret this result to mean that déjà vu could instead be a result of our brains being involved in conflict resolution. In other words, our brain could be checking through our memories looking for conflicts between what we think we've experienced versus what actually happened to us. When your brain is firing on all cylinders in a familiar environment and in a routine that it often repeats, it's easy to use a sense of familiarity for what you're seeing as a guide and scan back through your memory until you can recall the origin of the memory. But when your brain is tired, stressed, or anxious, or surrounded by the unfamiliar even, it might struggle to scan through everything that it's been exposed to well enough to perform this conflict resolution. Instead, you start having intense feelings of familiarity brought on by things that are evocative of what you've experienced before. This could be a particular configuration of cups or books on a table, a street that looks a certain way with a traffic light in a certain position, without being able to pin down why it feels so familiar. The brain will always go for the easy way out. It just decides that it's clearly been here before and done this before, and is happy enough with that explanation, so it doesn't bother to investigate any further. It was tired, after all. The split perception theory suggests that déjà vu is when you see something 2 different times and just weren't paying attention properly the first time. Apparently, the more distracted you are, the more likely you are to experience déjà vu. If you're distracted by something else and don't take in all the available information around you, your perception might be split into 2 parts rather than 1. Essentially, your brain recalls the previous perception, even if you didn't. This can slightly confuse your hippocampus, the part of your brain important for memory, processing, and navigation, and lead to that sudden and eerie feeling that you've seen it, been there, or done that before. How about this? The experience actually happened. Yes, you heard right, however unlikely that might sound. Sometimes when you have déjà vu, it might not actually be déjà vu at all. The feeling of familiarity could be happening because you've actually had the same experience in the past, but simply don't remember it. I'm not convinced personally, but a study did find that déjà vu can often be related to things you've seen and done, even if you don't remember it. Spatial awareness also seems to matter when it comes to déjà vu. Similar layouts of places can lead to the feeling, even if the 2 places look nothing alike. That's why the Sims experiment from earlier actually worked. Or maybe you just have a dominant eye. Most people have one, and apparently this could also contribute to feelings of déjà vu. If the stronger eye sends information to the subconscious before both eyes focus and register the input as a conscious experience, your brain sends a message to tell you that you've seen this before. And you have, but it was just a nanosecond ago. But then again, that wouldn't explain the more versatile forms of déjà vu, where it's less about sight and more about experience. A link that potentially ties all this together is consciousness. One of the recent theories aimed at trying to explain consciousness is about the brain's processing of information and our experience of that processing. It talks about a patient with hemispatial neglect resulting from a stroke. Pretty much, the patient lost awareness on one side of her body. Yet, she was able to process details about images with the unaffected side without being aware of actually seeing them. What this tells us is that a lot might be going on around us without us truly being aware of it. Or maybe it's just a glitch in the matrix. I know it sounds sci-fi and all, but if you entertain the notion that we might be in a simulated universe, the idea that something like déjà vu might be a glitch in the matrix is not hard to visualize. It might be that these strangely beautiful instances are products of a code error. Errors where the computers simply mess up the timeline for some of the players before quickly fixing themselves. Strangely enough, this theory has a remote bias in reality, albeit on the other side of the familiarity spectrum. Patients with a rare variant of Capgras delusions have reported that they feel time has been warped or substituted. Theoretically, a similar warping could also lead to déjà vu, but back to reality now. It's hard to deny the numerous different explanations, but the lack of a definitive answer leaves the phenomenon open to stranger theories still, and depending on your point of view, it's hard to discount them completely, however outlandish they might seem. As well as normal déjà vu, many claim to also have precognitive déjà vu experiences, containing knowledge of something that hasn't happened yet. Things like, I knew what he was going to say before he said it, or I suddenly knew what she was thinking. History is full of people that have reported intuitive hunches, premonitions, and forebodings later verified to be accurate, and much of this is explained away as misinterpretations of mundane effects such as coincidence, selective memory, confabulation, or even fraud. But the question remains, can all cases of apparent foreknowledge be explained in this way? It feels like an eye into the future. Is it possible? Well, maybe it's not so far-fetched. Although this particular explanation is not of the psychic kind, a new perspective on memory is fast gaining traction. And it proposes that memory's adaptive purpose is not so much to allow us to consciously remember our past, but instead serves to help us navigate the future. If you think about it, memory has the potential to help us navigate our futures in many ways, from our use of imagination and ability to be creative, or just by allowing us to know what to do next or how to react in situations. They say practice makes perfect, so maybe memories are just training your brain for the future. Déjà vu seems to be strongly associated with memory, so maybe it serves a similar purpose. If it is caused by an unrecalled, buried memory, then is it also possible that an accompanying sense of what will happen in the future could come from that same buried memory? I already mentioned that researchers have tried and succeeded in creating the feeling of déjà vu in the lab. Another way to create the sensation is to implant false memories, something that's surprisingly easy. With just a little suggestion, people will remember a specific memory of being lost in the mall as a child and being found by a kind old lady, despite the relatives confirming that that never happened. This form of déjà vu would be similar to the feeling when you can't differentiate between a dream versus something that actually happened. Some scientists argue that déjà vu is certainly related to false memory, in the sense that it is a memory dissociation kind of effect. It dissociates reality from your memory. You could also briefly expose someone to an object or picture, for example, a place, a painting, so on, and then let them go back and take it in more slowly, creating an actual memory that they may not be able to pin down. Researchers have had a lot of success with this type of induction, showing participants words, names, or faces for a split second, and then inducing the feeling of déjà vu by showing people the same thing for a longer amount of time, just moments later. But these are quite artificial, and maybe don't quite match the spontaneous sensation that comes with déjà vu in real life. I also think the sensation is more intriguing when it's moments of your own life that you've witnessed before, rather than implanted words or pictures. The bottom line is, it's really difficult to know whether what's being induced in the lab is real déjà vu, because we're relying on subjective accounts of a feeling from participants, and everyone will probably experience things differently, or have a different interpretation of what exactly déjà vu is. There's also the possibility that participants are simply telling a researcher what they think they want to hear, also known as demand characteristics. We can't rely entirely on the results of these experiments, and maybe the feeling of familiarity isn't just a byproduct of seeing familiar objects. It's a feeling all on its own with no existence in the past. Maybe that's what we should be investigating. Or should we? Some say that we shouldn't investigate déjà vu at all. The sense of mystery that is so deeply tied to the concept of déjà vu is perhaps why it's so beautiful. I don't know what causes it, but you certainly do. In fact, you've already watched this video before, haven't you?
The unconscious layer, dreams, time loops, and hidden signals. If you thought consciousness was strange, the unconscious mind is much stranger. Beneath the surface of waking life, the mind keeps going. Dreams, they don't make sense, yet we all experience them. In dreams, time bends, logic dissolves. We experience a whole lifetime in minutes and wake up with answers to questions that we never asked. In this state, reality is warped and everything is not what it seems. Are dreams random static or a secret code from somewhere deeper? We enter a world that defies logic, the signals we can't explain but also can't ignore. This is the unconscious layer.
Why do we dream? This is one of life's great unanswered questions. Given that we spend around 6 years of our lives in a dream state, it's no wonder people want to understand why we do it. Sure, there are theories, and I'll get to them. But there's no clear consensus on why we do it. No one really knows for sure. Or do they? Dreams are strange, to say the least, and for many of us, they hold great significance. So much that we like to share them with others at length, if we can even remember them, and try to interpret their secret and hidden meanings. So, do they actually hold any real meaning? Well, I have some ideas. Before we get to some of the bigger questions, let's just look at what goes on inside the brain as our nighttime adventures take their course. While sleeping, we go through different cycles of the 5 stages of sleep. These are divided into REM sleep and non-REM sleep. REM simply means rapid eye movement. It explains itself, right? The first 4 stages are non-REM sleep. These are restorative and, for the most part, dreamless. As we move through these initial stages, our brain activity slows. But about 90 minutes after we finally fall asleep, we hit stage 5, REM sleep. This is when the dreaming really gets going. When we're in this stage, the body is, for all intents and purposes, paralyzed. your heart rate goes up, your blood pressure rises, and brain activity returns to near waking levels. The paralysis in REM sleep is caused by the release of glycine, an amino acid from the brainstem, onto your brain's motor neurons. It's suggested that this paralysis is nature's way of preventing us from acting out our dreams, and that's probably for the best. The limbic system is a pretty primitive part of the brain that deals with emotions, and is very active during REM sleep. It's made up of the amygdala, which is mostly associated with fear, the hippocampus, which is heavily involved in the formation of long-term memory, and the cingulate gyrus, which is involved in our physical reactions to situations. Break down the roles of these bizarre brain structures, and we can start to paint a picture of why our dreams often take the bizarre and scary forms they do. Couple this with the fact that the prefrontal cortex, the part of the brain that deals with logic and self-control, isn't really active during REM sleep, and things might just start to make sense. But understanding it isn't enough to prevent these nightmares from happening. It can also happen while you're awake. Sleep paralysis is a terrifying concept. Like I just mentioned, when you fall asleep, your brain doesn't completely shut off. In order to prevent you from acting out your dreams while you sleep, the brain releases chemicals that leave you paralyzed. This paralysis is supposed to be lifted as soon as you wake up. But sometimes, it doesn't. And that's where you get sleep paralysis. You wake up, you're aware of your consciousness, but you can't move. It feels as if there's a massive weight on your body preventing you from actually waking up. Sleep paralysis is often most caused by disrupted REM sleep, so some people may believe they're still dreaming when they're in fact awake. Because of this, some of your nightmares could leak into the real world. While undergoing sleep paralysis, you'll often see things standing in the corners of your room, or on the ceiling, or even closer. Luckily, this usually goes away pretty quickly. So, is it just biology? Is that really the answer? Is there no secret window into our psyche? Everyone, at one time or another, has wondered what their dreams mean. Some believe that dreams have no meaning and serve no function, others believe that they're one of the most important things that human biology has allowed to happen. There's in fact many theories of why we dream and what purpose it serves. I can't really go any further without mentioning Freud. His theories of dreams are probably the most well-known around the world. It focuses on the content of the dreams themselves as an explanation of the function of dreaming. German psychiatrist Sigmund Freud theorized that dreams represented a window into the unconscious mind, a reservoir of feelings, thoughts, urges, and memories that are beyond our conscious awareness. The bulk of the iceberg submerged deep underwater. Most of the contents of the unconscious mind are supposedly unacceptable or unpleasant, representing feelings of pain, anxiety, or conflict. When we're sleeping, the forces that keep these feelings in check are weakened, allowing us to live out our desires and even fears through our dreams. Freud strongly believed that by exploring dreams, people could increase self-awareness and gain an insight into their unconscious self that would then help them deal with problems in their day-to-day lives. He also argued that the true meaning of our dreams is hidden within their actual content, and that interpretation is needed to understand how they relate to our unconscious fears or desires. Many of you watching might even agree with this. Despite the fact that there is absolutely zero evidence to back this account, it is pretty much unfalsifiable, even though more modern explanations now exist that are better informed due to a deeper understanding of how the brain works. 20th century Swiss psychiatrist Carl Jung also believed that dreams allow us to tap into the unconscious, but argued that it was a collective unconscious that we were able to access through our dreams. According to Jung, this is a theoretical repository of information shared by everyone, in which certain symbols in dreams have meanings that are similar for all people, regardless of culture or location. This could explain why so many of us share variations on common themes in our dreams, like falling, being chased, or our teeth falling out. Any of these sound familiar? Dream interpretation is the process of assigning meaning to dreams. Even today, the practice plays an important role in various forms of psychotherapy, which is surprising given that there is only a little evidence so far that shows understanding of interpreting dreams has a positive impact on mental health. This could be because evidence also shows that people tend not to attribute equal importance to all dreams. Motivated reasoning comes into play. People are more likely to view dreams that confirm their waking beliefs and desires as meaningful compared to dreams that contradict them. But just for fun, let's take a look at some interpretations of the most common dream themes. We've all had the falling dream, right? Well, this could be a warning from your subconscious, and is common in people who are having a major life problem with work or relationships. It could be an indication of insecurities, instability, or worries. You might be feeling overwhelmed and out of control in some situation in your waking life. This type of dream could also reflect a sense of failure or inferiority in some circumstance or situation. It's typically suggested that showing up to work or school naked represents vulnerability and anxiety. Clearly. Research has demonstrated that this dream is common in people who have accepted a promotion, gone off to a new job, or who are coming into public view. Others argue that it means you may be hiding something and are afraid that others can see right through you. And despite the nightmarish feel of dreaming that someone or something is chasing you, it can be considered a positive message and a little prompt from the unconscious to encourage the dreamer to face a problem they've been avoiding. It's suggested that who or what is chasing you and how far away they are is important. These common themes barely touch the surface of the complexity and endless variety and variations of dreams. We know dream interpretation can be entertaining, but there are definitely more contemporary theories about the purpose of dreaming that it's probably important to consider them too. A better understanding of brain function and activity have allowed for the development of neurobiological theories in more recent years, one of which is the activation synthesis theory. Not quite as intriguing as the psychoanalytic approach, in fact it's pretty boring. This theory simply rejects the idea that dreams mean anything at all, which is disappointing. They could be merely electrical brain impulses that pull random thoughts and imagery from our memories. Activation synthesis suggests that humans can create dream stories after they wake up, in a natural attempt to make sense of the absurd. I kinda get it. There are some holes in this theory too though, the main one being that there is vast documentation of the realistic aspects of human dreaming, and evidence that dreams do reflect real-life events that are important or prominent for the dreamer. For example, a study in 2006 asked women who were going through a divorce to report the degree to which their former spouses were on their minds over a 5-month period. These same women were awakened during REM sleep on 3 nights, and asked to provide a detailed account of their dream content. A positive correlation was found between the degree to which women thought about their former spouses during waking hours, and the number of times their former spouses appeared as a dream character. In another study, researchers demonstrated that dreaming can help solve complex mental tasks. Participants were much better, 10 times better in fact, at getting through a complex 3D maze if they had napped and dreamed of the maze before their second attempt. This strongly suggests that certain memory processes happen exclusively during sleep, and that our dreams are not only a signal that these processes are taking place, but seem to be crucial to better performance. So, unconstrained by reality and the rules of conventional logic, the dreams your mind can create have the potential to lay out limitless scenarios to work through problems and produce solutions that you may not have even considered while awake. So, it turns out that dreams can be influenced by pre-sleep emotions, and can be really helpful for problem solving. So that's another theory put to bed. The continual activation theory proposes that the conscious and unconscious mind must remain continually active in order to maintain proper brain function. In this context, dreams function to consolidate working memories into long-term memories, and dreaming is simply an incidental result of the brain's need for continual activation. This means that if the brain's activity falls below a certain level, such as during sleep, it is stimulated to maintain activity through dreams. The expectation fulfillment theory explains dreaming as a way to release emotional arousals that haven't been expressed during the day. This frees up space in the brain to deal with the emotional arousals of the next day and allows instinctive urges to stay intact. In effect, the action we wanted to take is completed in a metaphorical form, and this prevents a false memory being created because we perceive the action as a dream instead. So dreams are metaphors for unfulfilled arousals and expectations, but because sleep does not involve the same stimulation of waking life, dreams draw on memory instead of motor or sensory activity. It is this process that apparently generates the unusual imagery, narratives, and thought patterns we experience in dreams. This explanation has received validation anecdotally through people's personal experiences, but same old story, it is essentially unfalsifiable. Interpretation of dream events is subjective, so we aren't able to put this theory through rigorous scientific testing. I could go on with the theories for days, but you get the point. No one really knows. It's very difficult to disprove most theories. Maybe some of the more fascinating dream phenomena can shed light on the function of dreaming. The term lucid dreaming was coined by Van Eeden way back in 1913, although people were writing about this kind of experience as far back as the 1800s. It describes a state in which the dreamer is aware they're asleep, and sometimes has the ability to control events and actions. It most commonly occurs during late-stage REM sleep, and essentially allows your conscious mind to control something your unconscious mind normally controls. Lucid dreamers report being able to fly, taste, smell, and touch pretty much anything they want. It's more common than you think, with about 55% of people having experienced the state at one time or another. For starters, participants were asked to perform specific ocular movements if they became lucid while dreaming. By ocular movements, I mean moving your eyes, that's literally it. This is possible actually, and it's kind of ingenious, because eye muscles are free to move during REM sleep. By determining exactly when the sleeper was lucid dreaming, researchers were able to take recordings of brain activity during this state. The evidence showed some interesting and specific brain activity that represents a mixture of both waking and normal REM sleep. It also seems that the brain undergoes a specific altered state of physiology during lucid dreaming that constitutes a hybrid state of consciousness. Studies have shown that the prefrontal cortex, as well as the frontal, parietal, and temporal zones become activated. These areas of the brain are responsible for higher order cognitive functioning, including working memory, cognitive flexibility, planning, inhibition, abstract reasoning, the list goes on. So, besides being quite entertaining, why do it? Can we learn anything from it? Some advocate many potential benefits, including boosting creativity and confidence, reducing stress, and as a possible therapeutic technique to treat nightmares, PTSD, and other mental health disorders. Others view the practice as more spiritual and approach it the way they would a meditation, with the intention of increasing a person's sense of the vastness of reality, opening up new realms of discovery. It's even been suggested that some advanced meditation practitioners are able to become conscious of what is beyond the dream state, the deep formlessness of delta sleep. This is questionable at best and in need of much further study. Given our current relatively limited understanding of the brain, it's hard right now to understand how it could be possible to be conscious of deep sleep, because the brain is in a far more synchronized and deeply unconscious state compared to almost any other state of consciousness. But hey, who knows? Despite the evidence, lucid dreaming remains a controversial topic. Alternative explanations have been suggested for the phenomenon. It may be that lucid dreamers are in a daydream-like state of semi-wakefulness. Or are they dreaming normally but have a memory of the dream and believe that they were conscious and directing the dream but were not? It could be a sleep state dissociation, in which the person is both awake and asleep in the dream state at the same time. I suppose it's even possible that people aren't reporting true experiences, but I personally don't think this is what's going on. If lucid dreaming is as real as the evidence suggests, I'm left wondering if dreaming serves any of the purposes I've already talked about, such as accessing the unconscious, acting out instinctive urges, solving problems, or whether they're simply electrical impulses keeping the brain from shutting down. How does being a conscious witness affect how they play out? Does it hinder or help? Is it a state of heightened reflective consciousness that humans are meant to access so that we can enlighten ourselves about our life, our world, and our purpose? Or does lucid dreaming stand alone in its function to serve an entirely different purpose? Have you ever dreamt of an event only to find out that it happens in your waking life? It's a weird occurrence. Precognitive dreams are dreams that appear to predict the future through a sixth sense, and there's some pretty famous examples of this happening. When the Titanic sank in 1912, hundreds of people came forward with reports of psychic dreams about it sinking. It was even possible to validate at least 19 of them, including a date-stamped letter. Several people apparently canceled tickets and decided to not travel based on their dreams. Are all 19 of these people psychic? Well, no. In fact, in this case, it's likely to be simple math and the power of probability. Think about it. There's 7.5 billion people on this planet, each having an average of 5 dreams per night, whether you remember them or not. In turn, those dreams support multiple common dream themes, including events like sinking ships and airplane crashes. When all of this is considered, in reality, it's highly likely that many thousands of people will dream about a sinking ship on any given night, probably tonight too. Now, add in a bit of unconscious insight and media suggestion for a good measure. The Titanic was the world's largest ship on its maiden voyage, and was in the headlines before it even undocked. The media had called it unsinkable. The power of suggestion is immense, and it's no surprise that all this news, attention, and maybe even some nerves about taking such a huge trip infiltrated more than just a few dreams. So, the next time you dream about an event that has nothing to do with you and it comes true, it's probably just a coincidence. Probably. But what about dreaming of your own death? This is a deeply personal experience, and probably not subject to extensive media attention. It's exactly what happened to Abraham Lincoln. 2 weeks before he was shot dead in 1865, Abraham Lincoln had a dream about a funeral at the White House. When he asked someone who was in the casket, they replied, "The president, he was killed by an assassin." Clearly, he didn't listen, because at the time he was assassinated, he had given his bodyguard the night off. If the premonition dream is about something close and personal to you, some might argue that your subconscious mind is accessing a piece of information that you weren't consciously aware of in your waking state. You just missed it. The brain has so much to process every second you're alive, it only makes sense that some information is lost. So it's less psychic power and more inner feelings or intuition that you're experiencing through your dream. And this takes us neatly full circle back to the question of why we dream. If you don't believe in psychic abilities that manifest in dreams, then precognitive dreams are essentially the window into our unconscious. Of course, as always, Some disagree with these explanations of precognitive dreams, and suggest that when matches occur on such a reliable and frequent basis, this can't be entirely down to coincidence. Some of these people turn to a mix of philosophy and physics to understand how precognitive dreams might happen. To truly understand these theories, it is necessary to assume that the future consists of many possibilities, and which one becomes reality is determined by the choices we make. The butterfly effect shows up yet again. Ultimately, common sense would tell us that dreams likely serve many purposes as opposed to just a single one, and how we choose to understand our dreams and why they happen is largely a product of time and culture. The function of dreams may have even changed as humans have, and continue to change across time itself. What once acted as a rehearsal system for evading predators is now serving to help us navigate the social and technological complexities of modern life and its stresses. Dreaming is vital. The link between dreaming and REM sleep is undeniable, as are the benefits of REM sleep for our health and well-being. So don't stifle them. They're only trying to help you. Sweet dreams. Have you ever had a dream that came true the next day? Have you ever had a vision of the future and then watched it play out in the real world? Have you ever had a feeling that something big was going to happen, and then it does? You are not alone. One night, the famous American writer Mark Twain awoke from a horrible dream. Mark saw his younger brother Henry laying in a metal casket, dead. On his brother's chest was a bouquet of white roses with a single red rose at the center. When Mark woke up, he was stricken with a sense of grief, as if his brother were really dead. But he wasn't. Henry was still alive. Still, his nightmare was so specific that it left Mark with a sensation of being more of a vision than a dream. The white roses with a single red rose at the center and the coffin being metal and not wood was particularly strange. At the time, wooden coffins were the standard. Mark was eventually able to calm himself down, and he dismissed this vision as only a dream. In the real world, Mark and Henry got a job working together aboard a river boat. But Mark was soon transferred to another vessel after he got in a fight with the boat's captain. So the two brothers were separated. Mark went one way and Henry went another. A few weeks after his dream, Mark got word that his brother Henry was dead, killed in an explosion aboard the riverboat. Mark was summoned to where his brother's body was being prepared. When Mark entered the room, he was horrified to see the scene from his dream exactly as he dreamt it. Henry was lying in a metal casket. As shocking as this was to see, a small detail was missing. There were no flowers, no bouquet of white roses with a red rose at the center. The nightmare must have been just a coincidence, right? Here's the twist. Before Mark leaves his brother, a woman carrying a bouquet of white roses with a red rose at the center enters the room. Mark Twain dreams of his brother's untimely death and gets every detail of his siblings' demise correct, right down to the color of the flowers and the unique type of casket. But he isn't the only luminary from the past to dream about the future. Abraham Lincoln reportedly dreamed of his impending assassination. There are records of passengers meant to board the infamous Titanic who dreamed of the catastrophe before it occurred. As a result, they didn't take the trip. These are only a few of the thousands of reported cases from all over the world of people dreaming up accurate visions of the future. This phenomenon is known as precognitive dreams. But how is this possible? Is it all just coincidence? I can't claim to believe in precognitive dreams one way or the other, but a story sent to me got me interested in the topic. It's a story I will share with you at the end of this video. A story you may find hard to believe. But first, I'd like to provide a little background and context that got me thinking that the story isn't so hard to believe after all. But what is precognitive dreaming? A study by the American Psychological Association defines a precognitive dream as a dream that seemingly includes knowledge about the future that cannot be inferred by some prior knowledge. In other words, they have a vision of the future that does not draw on input from the five senses, memory, or logic. Have you experienced something like this before? It's likely that you have, and given the nature of dreams and the uncanny feeling they leave you with, chances are you remember them. Although precognitive dreams are categorized as paranormal, research suggests that they are quite common. Up to 38% of large samples of people reported having at least one precognitive dream. Women report having them more than men, and the frequency of them occurring seems to decline with age. In 1989, a meta-analysis published by paranormal investigators Charles Honorton and Diane C. Ferrari cited over 2 million trials conducted between 1935 and 1987 on 50,000 random participants. The goal was to discover if precognitive dreams are more than just coincidence. And the results are shocking. The study concluded that there was only a 0.0975% chance that coincidence had anything to do with the descriptions of future events offered by the participants. But is the ability to have these precognitive dreams so unbelievable? What if they are more akin to something like instinct? And we don't debate the existence of instinct, right? Instinct almost always comes with a physical sensation. A study by Northwestern University investigated the hypothesis that human physiology can predict important future or emotional events. In this study, participants were shown pictures at random. On average, participants experienced physiological changes like sweating before they were shown a picture of a gun, but this is hardly a modern phenomenon. The Babylonian Epic of Gilgamesh is one of the oldest surviving works of literature that dates back to 2100 BC. In the story, dreams are regarded as visions of the future. Aristotle published a paper called On Prophesizing Dreams. In it, he concludes that precognitive dreams are possible, but that most of them are probably coincidental. Are precognitive dreams only mere coincidence? People can't really predict the future, can they? It depends on what you believe about time. When you're awake, does it feel like time is linear, moving forward, or is this an illusion? First, let's go with the assumption that it is linear. And if it is, then our ability to predict the future is impossible, right? The idea of knowing the future before it arrives is logically incoherent. Newtonian physics is built upon the concept of materialism. This is the assumption that matter is the basis of everything, so consciousness is merely a byproduct of physical processes. And this strictly physical world operates on the principle that time flows in one direction. This is known as the principle of causality. Thing A causes thing B, and thing B only happens because thing A caused it to happen. Your coffee mug shattered on the floor because you dropped it. Precognitive dreams violate the fundamental principle that an effect cannot occur before its cause. But this Newtonian materialist worldview has not been adopted by everyone. There's another theory, the theory that consciousness is a fundamental part of reality itself, and something so much more than a byproduct of brain activity. One of the most unbelievable theories in quantum physics is the theory that an observer can affect reality simply by the act of observing it. What's even more unbelievable is that this has been proven to be true. On the quantum level, it all comes down to qualia and quanta. Qualia is conscious awareness, and quanta is this discovery that objects observed at the quantum level are extremely sensitive to being observed. Nobody likes the feeling of being watched. This feeling often produces physiological changes in our bodies and results in us changing course or acting differently than we otherwise would have. And you've probably heard of teleportation, which on the quantum level really is possible. It's much like Schrodinger's cat, where the cat is simultaneously alive and dead. The cat exists in two different states at two different times, simultaneously. You could think of precognitive dreams as the passing of information. And we know from our Wi-Fi signals that the passing of information can defy all kinds of laws, and what is being teleported in the quantum world is information, not matter. Newtonian physics and materialism simply cannot explain this phenomenon. But quantum physics can. Kind of. According to Einstein's theory of general relativity, time is just another dimension in space, and you can traverse this space in either direction, forward or backward. Quantum physics and general relativity supports the theory of a block universe, which is to say a four-dimensional universe. But existence as we experience it is only three-dimensional. You are a three-dimensional being living in a three-dimensional world. Physical objects in the three-dimensional world have height, width, and depth, and they take up space. Stay with me here because we're jumping from a three-dimensional world into a four-dimensional one. There is a four-dimensional space-time structure where time is just like space. Space and time both have coordinates, or addresses in spacetime. Time does not have a tense as in past, present, and future, so all points in time are equally real. The past and future are no less real than the present. They are all occurring simultaneously. Like physical objects in the 3D world, time takes up space. This challenges the notion that the past already happened and so is gone forever. And the future doesn't exist yet, so it's inaccessible. This leads to the many worlds, or multiverse, theory. This theory states that at each moment, a new possible future splits off into a whole new timeline. This would explain how particles can exist in the same place at the same time. But this theory hasn't yet been proven. It can't be empirically tested because we just don't have access to those other timelines. Or do we? A common vision or warning in precognitive dreams is that of car crashes. The dreamer witnesses their own death while being behind the wheel, and as a consequence, they refuse to drive to work the next day or take a different route than normal. In effect, ending one timeline and splitting off into another. Another common warning is that of illness. In a study of warning dreams preceding the diagnosis of breast cancer, each participant had similar dreams that shared the same characteristics. Each dream had a sense of conviction about the importance of the dream. Each one was more vivid, real, or intense than ordinary dreams. Each one had an emotional sense of threat, menace, or dread. Warning dreams of breast cancer were often reported to be life-changing experiences that spurred the participants to get checked right away, which led to early diagnosis. Had the person not had the dream, the cancer could have gone undiagnosed, and for some, their timeline would end, perhaps prematurely. So what is it about sleep that allows us to do the impossible and break the linear flow of time? Is time both real and not real? What about the physical barriers of the world, both real and not real? This is a paradox, and that's the word I want you to keep in mind as we continue. Paradox. You've probably heard of REM sleep, but have you heard of paradoxical sleep? Paradoxical sleep is a part of the sleep cycle where the brain is incredibly active, but our body is unable to move. Brain scans indicate that the brainwave activity during this part of sleep is almost identical to brainwave activity while we're awake. For all intents and purposes, our brain thinks we are awake, and yet the body is, in effect, paralyzed. During this stage of sleep, the brain's limbic system is in overdrive. The limbic system contains the amygdala, the hippocampus, and the cingulate gyrus. These parts of the brain are responsible for our 5 senses and emotions, long-term memory, and muscle movement respectively. Though we're sleeping, our brain is still busy interpreting visual cues and sensations without external stimulus or input. So we are awake, but not awake. We are simultaneously experiencing the world, and yet we are not. Hence the paradox. This brain activity during sleep supports studies on the top-down connection between the unconscious mind and the physical body. The first empirical demonstration of this mind-matter interaction was achieved in the 1990s, when scientists concluded that guided imagery and self-hypnosis enhanced immune function. You could say that the simple act of behaving differently after having a dream is an example of your consciousness having a real, tangible consequence on the physical world. But how many dreams are ignored because they don't predict anything? There are nearly 8 billion people in the world. On average, the majority of them have multiple dreams each night. And when it comes to precognitive dreams, people aren't dreaming of alien invasions or zombies walking the earth. Though the content can be warning of something tragic, they are still mundane, possible, and plausible occurrences. If that many people are having that many dreams, doesn't it stand to reason that every now and then a dream is just a really good guess or coincidence? I'd like to leave you with the story I spoke of earlier, and let you decide. The following story happened in Montreal, Canada in 2022. After yet another negative pregnancy test, Bill and Kate had all but given up trying to have a baby. They had the dog, and that would be enough. But one night, Bill had a dream. In it, he held their dog in his arms, but when he looked down at it, the dog had a baby's head with a furry body. Bill doesn't tell Kate about the dream, until the moment he has to. In the real world, Bill and Kate take the dog for its morning walk. Kate stops when she notices the dog has something in its mouth. Kate bends down to see what the dog has found. She holds the something up to Bill, and Bill's jaw drops. In her hand, Kate holds a tiny doll with a baby's head and a furry body. Bill tells Kate about his dream. The couple races home where Kate takes a pregnancy test. Then another. And then another. All three came back positive. Bill and Kate are going to have a baby. Maybe, just maybe, we really can see the future. Imagine you're flying, feeling the cold air on your skin, flooded by light. You look down and see a sandy beach peppered with palm trees, and you decide to go there. Suddenly you're on the beach drinking a pina colada, but you're alone. Wouldn't it be nice if somebody was there with you? And then suddenly your best friend appears. It's comforting and warm, a feeling you know you've been craving because you've been struggling at work recently. You're grateful for their encouragement and for the pina colada. It's your favorite drink after all. You take a deep breath and enjoy the beauty of the moment. But it isn't a vacation, it isn't a game or a VR headset. It's a dream that you know you're in, a dream that you can control. The beach, the drink, the friend, you made it all happen. Because you're lucid dreaming. Lucid dreaming occurs when a sleeper is aware they're in a dream and can exercise some control over the environment of the dream. In a regular dream, we're aware of objects and events within the dream itself, but we're not aware that we're dreaming. We can't distinguish between being asleep and being awake. Lucid dreaming isn't anything new, it's a phenomenon that's been reported throughout history, but only scientifically documented since 1975. And a lot is still unknown about it. Why it happens, how to induce it, and what effects it might have on us individually and as a species. Some scientists believe that lucid dreaming comes from increased activity in the prefrontal cortex, and unlike non-lucid dreams that can take place anytime while we're sleeping, lucid dreaming happens during our rapid eye movement or REM sleep cycle, our fourth and final, deepest stage of normal sleep. But the biggest thing that those of us who haven't had the pleasure of lucid dreaming are wondering is, what's it like? Lucid dreamers have described feeling like they're playing a virtual reality game where they have some control over aspects of their scene and setting. These dreams can also leave lasting impressions that might be stronger than those we experience when we're awake. Most of us have had the experience of waking up from a dream, even one we can't fully remember, and feeling somehow changed from it. With lucid dreaming, that change or impact we might feel is much more visceral. Some lucid dreamers have talked about their dreams in religious terms, like an out-of-body experience. Some even say it feels like being temporarily abducted by aliens and transported to a different planet, like you're in your own personal video game. But one of the most interesting aspects of lucid dreaming is the emotional revelations that can happen in them. In a lucid dream, you might be introduced to elements of yourself you might not see otherwise. You might see yourself more sympathetically, kinder, braver, or more sensitive than you'd like to admit or take credit for in reality. In this sense, lucid dreams might offer some introspection that many of us hesitate to ponder in our waking lives. Now it all might sound pretty amazing and you might be envious if you've never experienced a lucid dream, because I know I am. And we're not alone in that envy. There's a subreddit with more than 400,000 members dedicated to the subject of lucid dreaming. However, only 23% of the population experience lucid dreams on a monthly basis, and less than 1% of people are what scientists call proficient lucid dreamers, people who can easily sink into and manipulate their lucid dreams. But the good news is that a majority of adults, 55%, claim to have experienced at least one lucid dream in their lifetime, so if you haven't had one yet, the odds are in your favor. And if you want to up the odds, here are some things you can do to pave the way to your lucid dream journey. First is to optimize your bedroom for sleeping. Good sleep hygiene is key to lucid dreams. 65 degrees Fahrenheit or 18 degrees Celsius is considered the ideal sleep temperature, and it's important to keep your room relatively quiet and dark. Invest in some blackout curtains, sleep masks, or other accessories to reduce light, and consider using earplugs or a sound machine to block out disruptive noise. Another critical element to lucid dreaming is what researchers call reality testing. This consists of checking in with your environment and confirming whether you're asleep or awake. We all know that our dream environments can look familiar to our waking reality, but there's always some minor inconsistencies compared to reality. Performing these reality checks while we're awake can give us the skills to determine when we're in a dream. Reality testing is specifically helpful when something odd happens in your waking life. If you see a strange animal cross the street in front of your car, take a moment. Think about the fact that you're awake and that the animal is real and that this odd moment is happening in your life. Developing that critical frame of mind when you're awake will ideally carry over into your dream state. Reality checks can also be quite simple, like pressing your fingers against your palm and feeling the resistance of your hand. In a dream, you might notice that your fingers go through your hand, and at that point, you'll know you're not in reality where scientific laws apply. Or take note of being in your waking reality when you're reading, because in dreams, written words often appear jumbled. It can also be helpful to wake yourself up after 5 hours of sleeping and simply tell yourself to remember you're dreaming when you go back to sleep. Research has found that this technique is most effective if you can stay awake for 30 to 120 minutes before sleeping again. Another tactic you may already be doing is keeping a dream journal. Recording our dreams helps us recognize dreams more easily, since many of our dreams or elements of them repeat. You might want to write down what you remember the moment you wake up, or even record a voice note on your phone to rattle off bits and pieces that come to mind. As interest in lucid dreaming has grown and these kinds of tips have proliferated on the internet, a whole industry has grown around the goal of lucid dreaming. There are now sleep masks and headbands you can buy that produce noises, flash lights, or vibrate to inject stimulation into your dreams. These are methods used by researchers on lucid dreaming subjects. There are online tutorials, some helpful and some from people simply looking to capitalize on the craze around lucid dreaming. And there are even supplements that have been shown to induce lucid dreaming. The drug alkaloid galantamine has been used in research and home settings to encourage lucid dreams. One study showed that participants who took the drug after being woken up and practicing visualization were more likely to lucid dream than participants who received a placebo. Galantamine is already available over the counter as a supplement, and many lucid dreamers say that it helps them stay in the dream longer and have more control over elements of their dreams. Of course, some view using drugs as cheating, just as you would with any performance-enhancing substance in sports. But proficient lucid dreamers rightly stress that whether you use a supplement or not, you need to practice lucid dreaming using other methods. Simply popping pills won't get you there. But if you do manage to get there, into a lucid dream, what do you do? Once we're lucid dreaming, we want to use that moment to control where the dream goes and try to assert influence over what happens. This works better if, instead of willing something to happen, we simply expect it to. Imagine you're back on the beach with your friend and you want a beautiful sea turtle to come climbing out of the water. Instead of insisting that the turtle will show up, expect it to be there. Once you do, a sea turtle or something close to it will probably appear. That expectancy effect can help things appear in our dreams. If we say, "I'll find the dog behind the couch," when we look behind the couch, the dog will be there. Experienced lucid dreamers can also open doors in their dreams and envision what they want to be on the other side of the door. Perhaps you can open a door and transport yourself from the sunny beach into the middle of outer space. Most of what we know about lucid dreams comes from the early stages of research into the topic and from those who can have the dreams. We still don't have a great understanding of the neural underpinnings of lucid dreams or the brain processes that make them happen, and at this point we don't have a reliable way to induce them. But even with so much unknown, we do know that there are benefits to lucid dreaming. At the very least, a lucid dream can act as a sort of wish fulfillment, taking us to places or putting us in situations we've always wished we could experience. Lucid dreaming can also help us shed the stress of daily life. It's been clinically shown to be a potential treatment for pervasive nightmares, and data shows that lucid dreaming can foster creativity. Even athletes will employ lucid dreams to work on and refine motor skills. Most of all, lucid dreams allow us to interact and explore parts of our unconscious that we can't when we're in our regular dreams, or even while we're awake. Of course, this level of awareness in our unconscious state can present its own problems. Skeptics worry that lucid dreaming can have a negative impact on mental health, not only because it can disturb sleep, but also because it can blur the lines between reality and fantasy. Remember the reality testing tactic to induce lucid dreams. While it might help some distinguish between waking and dreaming, it might also make others question whether they're awake or asleep. This would be disorienting. It could lead to a feeling of dissociation where they feel disconnected from their thoughts, feelings, and sense of identity. Still, the curiosity around lucid dreaming is impossible to resist, and not just for you or me, but for researchers. In an effort to answer the question of what exactly is happening when we have lucid dreams and how to better understand how to trigger them, researchers have invited proficient lucid dreamers into their labs. Once the participants are asleep, Researchers measure activity levels in the prefrontal cortex and other areas. The participants are told to use left and right eye movement once they're in a lucid dream and aware that they're dreaming. This way, researchers can see what brain activity is happening in the brain at that very moment. Studies also tell us that the events we experience in our dreams produce effects on our brains that are similar to what would happen if we experienced them during our waking hours, and if that's true, then it would mean that dreaming of doing something is the equivalent of actually doing it. That might be a stretch if we're talking about like going to Mars or breathing underwater, but if it's a meaningful conversation with someone or tasting a new delicious food, maybe we could take the feeling and carry it with us into our reality. Because lucid dreaming might not just be about experiencing our dreams differently, it might be the key to understanding our own consciousness. English aristocrat and writer Mary Arnold Foster wrote one of the earliest and most detailed descriptions of lucid dreaming in her book Studies in Dreams. She described her attempts to fly, and she proposed that humans have dual consciousness. One is our primary self, which analyzes our circumstances and applies logic to our experiences. For most of us, this consciousness is typically enacted during sleep. But according to Foster, this primary self wakes up in lucid dreams and brings memories, knowledge, and reasoning from our waking life, along with the awareness that we're asleep. This idea of dual consciousness may not be scientific enough today, but researchers would agree that lucid dreams involve increased self-awareness and reflection. They give us the ability to think more deeply about our lives because we get to actively live outside of them. When we sleep, we still are who we are. Our brains are the same, but they're unconscious, so lucid dreams can provide a point of comparison to isolate the regions of the brain that are involved in the state of heightened self-awareness and agency. As much as many of us simply want to have cool dreams, lucid dreams aren't just about experiencing the feeling of flying or traveling to mystical places. They can have real scientific implications. If we're able to understand what's happening in the brain when it appears to be unconscious but is really aware, we can better treat brain injury patients who are unconscious. Doctors could establish these patients' levels of consciousness and treat them accordingly. If scientists can establish a neural signature of self-awareness by studying lucid dreamers, they can make more accurate diagnosis and prognosis. And what these ideas tell us is that lucid dreams are really about self-awareness. So even if you can't manage to get yourself into a lucid dream, you can still learn from them. Try to be more connected to your unconscious self, maybe not through a lucid dream, but through something more accessible, like meditation or other therapies in your waking life. Like all things, lucid dreaming takes practice. We have to approach the desire to lucid dream with a sense of calm. When we try to force it into existence, we lose the potential to find it altogether. So maybe we should start with a sense of curiosity, not just about what it would feel like to fly, but about what might be lurking in our own brain that we just haven't found yet.
The human layer. Meaning, illusion, and identity. We invent meaning to make the chaos more bearable. Stories about life, love, and purpose, about who we are and why we matter. But what if those stories are illusions too? In this layer, we confront the terrifying possibility that meaning isn't something we discover, because it simply doesn't exist. Or at least not in the way that we commonly think. This is the human layer.
Life is hard. I bought a new pair of shoes the other day, walked outside into the rain, and ended up stepping into some mud. Now they're ruined, and I'm bitter. But then I took a step back. Not literally, of course, but I really thought about it. And I came to the conclusion that nothing in life really matters. Here's why. The Earth has been around for 4.5 billion years. One day, humans became a thing, and we became conscious. This world seemed perfect for us. It wasn't scorching hot, it wasn't deathly cold. We fit right in the middle. The gravity on Earth was perfect. It allowed us to move and run and catch animals that conveniently existed for us humans to eat. There was water to drink, there was oxygen to breathe. It's as if we were put here for a reason. We began creating things. We began working together as a species, building empires, covering the planet, and fighting each other for whatever reason. Fast forward a couple million years, and here we are today. Computers, rockets, Elon Musk, they're all here. Somewhere along the line, we also, in a way, created something out of nothing. It's called time. We've laid out definitions of time, seconds, minutes, hours, years, but it doesn't really matter. We made those for our own use. Time is nothing more than a way to measure the passing of events. but we've only really set up these units of time based off of ourselves. A day is how long it takes the Earth to spin around once. A month is about how long it takes the moon to orbit the Earth, and also spin around once. A year is how long it takes the Earth to orbit the Sun once. You get about 78 Earth revolutions around the Sun in this journey called life. As poetic as that sounds, there's not much scale to these things once we pass a human lifetime. Sure, we can judge how long 1,000 or maybe even 10,000 years are, but after that, the timescales of things are just too much for our brains to handle. As much as you think you understand the 13.8 billion year lifespan of the universe, you really can't put that into an imaginable scale. On the scale of a human life, the universe is unbelievably old, but in terms of the universe's lifespan, pretty much nothing has happened yet. It's barely even started. We can make predictions about the next hundreds of trillions of years of the universe's life. We can figure out how and when our sun is going to blow up. We can figure out when our galaxy is going to collide with another. We can come up with theories that describe why the universe we've been put into is expanding faster than anything else physically possible. But yet, we have zero idea what happened in the fraction of a second between when there was nothing and when there was something. For some reason, as far as we can tell, we're the only conscious beings to have ever existed. But we don't even know what being conscious is. We developed consciousness only to be aware of the fact that nothing else is. We've grown so aware of our surroundings that the smarter we get, the smaller we become. As this thing we call time goes on, we begin to realize things. Things that prove that the universe probably wasn't made just for us. You were most likely born in a hospital. If not, props to you for making it this far. Back then, you were your parents' entire world for a small time, which is cute, but you aren't everything. 360,000 people are born each day. Of all of those people with the same birthday, some are going to do big things and change the world. Others are just gonna die. That just happens. But Earth is just one planet. In our solar system, there's 8. Or 9 of those. For now, for life as we know it to exist, it's kinda hard to believe that there might be other life out there. It takes so much to happen for us to be able to exist. We've discovered over 4,000 exoplanets to date, planets that don't revolve around our sun, and we've found multiple examples of Earth-like planets. Roughly the same shape, size, temperature, but yet there's nothing there from what we can tell. So if there are so many planets that could have life, why haven't we seen it yet? Why are there no signs? Well, we're just one solar system in an entire galaxy. There's over 200 billion stars in our galaxy alone. But that's just one galaxy. We're a part of the Local Group, which is a collection of 30 galaxies near our own. Andromeda is one of them. That's the one that's going to collide with our galaxy in about 4.5 billion years. By then, you'll be long gone. And soon after that, so will the Earth. The Sun at this point will be reaching the end of its life. It's going to expand in size, and by the end, it will completely consume the Earth, shining over 3,000 times brighter than it does today. But even though our home planet will be gone, the rest of the galaxy wouldn't even notice. Billions of years on a multi-trillion year timescale is truly nothing. But even so, there are some things that we're observing in the universe's infancy today that will drastically influence the far future. To keep it short, the universe is expanding. This is nothing new. A lot of people know this, but what many people don't know is that this expansion is speeding up. Now, we don't know why, but we have an idea of what's causing it. Dark energy. I made an entire video about this, so go watch that after. This dark energy is stretching the fabric of space-time. We don't know what it's made from, we know it's there, we observe its results, but we don't know exactly what it is, or what it's going to do. Dark energy, at least according to our current calculations, will eventually stretch the space-time between galaxies faster than the speed of light. The light emitting from our neighboring galaxies will travel towards us at the fastest speed possible, but even this won't be enough. The light will never reach us because the space between it is stretching faster than the light that is traveling through it. It will spread the universe so thin with galaxies that when we look out to observe what's around us, we won't see anything. We're going to end up all alone, confined to whatever galaxy we end up in. But in the end, even our galaxy will start to go dark. The fate of the sun is the same as it is for all stars in the universe. Eventually, trillions of years down the road, these lights in the sky are going to begin turning off, one by one by one. Without any new stars to keep things running, the universe is going to get a bit colder. Depending on their size, these dying stars begin to turn into white dwarfs or neutron stars, providing the last glimmers of light in a cold and dark universe. This is the very last hope for any surviving life forms in the universe. But eventually, trillions of more years after the last stars like our sun die, even these white dwarfs will begin to dim out. Some of these neutron stars roaming throughout the universe may collide by chance, resulting in the brightest known events in the entire universe: supernovae. But once these supernovae conclude, the universe is again plunged into darkness. All matter that used to make up the galaxies we see today will begin to fall into the black holes that kept things held together for so long. The Big Bang that created the highest temperatures ever known to physics ultimately results in the most dormant, dark, and cold configuration possible. From a universe teeming with light and beauty, to a cold, barren wasteland. A universe dominated by black holes. But even now, the universe has just begun. These black holes are going to be around for a while, and the things we used to call galaxies, with stars and planets and life, are now just going to be full of black holes, and more black holes. This is how the universe is going to spend most of its time. Cold, dark, and alone. We're no longer talking about millions of years here. The timescales are now on quadrillions of years. But even these black holes won't last forever. Through Hawking radiation, these black holes will slowly, very slowly, begin to evaporate away, one subatomic particle at a time, until eventually, after all the black holes fade out of existence, there is nothing left in the universe. A universe where nothing changes, where time becomes pointless. There's nothing. The nothingness of space, though, will continue to expand because of dark energy, a force that accounts for 70% of our universe that we don't even completely understand yet. Matter as we know it today, the things that make up everything you see, only accounts for barely 4% of the stuff in the universe. So maybe, just maybe, we're a fluke. We were never supposed to make it to the end, but we still have a role to play out today. We are one species on one planet, in one galaxy, in an almost indistinguishable part of the universe. Whether or not we came to exist, not much would be different. Every day we matter a little less, and a little less, until eventually we realize that, in the grand scheme of things, we don't matter at all. Our galaxy could just disappear. It wouldn't really change much. We came to exist in such a weird time, but it's also pretty unique. We know we're just the beginning, a blip in the universe's potential, but the only way to fulfill that potential is to start making progress today. It's not a stretch to say that there won't be others like us, random spurts of intelligent life spread throughout trillions of years. But now, we're at one of those stages where life is possible, and probably the easiest it's ever going to be. You get one life to do whatever you want. There are some things you can avoid, like school, or taxes. But other than that, you're free to do mostly whatever you'd like. If we can't figure out our purpose for coming to exist on this planet, if we can't figure out why or how the universe came into being, then our purpose is whatever we want it to be. If you want to sit around and play games all day, there are people doing that. If you want to build a multi-billion-dollar company that's going to help propel humanity to other worlds, there are people doing that as well. Anything you want to be or do can be done, and should be done. Like I said, our own purpose is whatever we want. Right now, if good things are happening to you, if bad things are happening to you, it's actually not gonna last forever. You have zero idea what the future holds for you, and the most random of experiences can reroute your future in an instant. Everyone was dealt a hand in life that we honestly just didn't ask for. Some people's hands are better than others, but we all have to play with the cards we've been given in the best way we can. There's a chance that we humans may never figure out why everything in the universe acts the way it does. Is there life anywhere else, or are we the exception? For every answer, 100 new questions pop up. There's infinite possibilities as to how we came to exist, but there's infinitely just as many things to do while we're figuring that out. There's dogs to feed, there's people to meet, there's science to be done. So whatever you do while we figure out our spot in the universe, this universe at least, just try to enjoy it. Because no matter what happens to you, no matter how many times you mess up, no matter how far humanity ventures out into the unknown, in the end, it doesn't even matter. This is green, this is red, and this is blue. But how can you tell what you're seeing as blue is the exact same thing as what I see as blue? We've named the colors to give us a way to communicate and reference them. But in reality, there's no way of knowing what you see is the same as what another person sees. Even with the small steps and the giant leaps we've made as a species, there's still a lot to learn about Earth, life, and the human condition. There's still everything we don't know. On the 26th of February 2015, one picture of a dress divided the internet.
You are seeing white and gold. Where are you looking at?
Oh, it just changed to white and gold!
Wait, no, you're kidding.
While some saw it as gold and white, others saw it as blue and black. And ever since then, there's been a number of repetitions of the same experiment, either using the same sense, in this case sight, or even other senses, like hearing, in the famous Yanni or Laurel debate.
Laurel.
These experiments remind us that there's no way for us to tell that you and I sense the same things. What I call red might just be what you call blue, and there might be someone out there who sees human beings with purple teeth, but just refers to it as white. 71% of the entire Earth is covered by water. Humans are made up of about 60% water, potatoes 80%, watermelons 93%, and cucumbers 95%. It's very clear that water is essential for life on Earth, but we really don't know that much about water, not even about the very oceans we came from. In fact, we've only explored 5 to 10% of the Earth's oceans. The rest, well, who knows what's down there? It's even scarier when you realize that fish, like the blobfish and the barreled eye fish, belong to the slim percent of things that we've already discovered. The deeper you go, the crazier things seem to get. What's at the bottom of the ocean? For the most part, we just don't know. But back on the surface, countries that are bordered by water use something called coastlines to mark their territory. The coast is the land along the sea, and the boundary between the coast and the sea is known as a coastline. So, how long is the US coastline, or any other coastline in the world? The answer is, well, again, we don't really know. Coastlines constantly curve and cut in and out. Even the smallest deviations from a straight line can add distance, and over time, these small distances add up. Some of these features are massive, like bays, while others are minuscule. Now, measuring each and every little crevice isn't really efficient, so surveyors cut corners and straighten rough edges into easily manageable lines. If you do a quick Google search of the measurement of any coastline, you'll find a lot of different answers. They all cut corners, just differently. Humanity as a species, though, well, we've done really well for ourselves. When in a pinch, we invent something to push us through. We made clothes when the weather was harsh, shelter so we could be safe from wildlife to rest and recuperate, weapons to hunt for food, money to replace pure bartering. But what about fire? Was fire a discovery or an invention? And music? Music has been described by scientists as a relatively recent invention by humans. It's believed that music helped our ancestors to bring together a close-knit community. But did humans really invent music? Or did we just discover that certain sounds sound nice with other sounds? Birds sing, whales sing, even tree frogs have a nice rich baritone sometimes. So can we really say man invented music? If we did, then what is the true definition of music? I guess we'll never know. On the list of man's greatest inventions has to be tools. In fact, for a really long time, scientists were pretty sure that this is exactly what made us human. We were the only animals who, through the use of such a variety of tools, were able to expand and grow so quickly. Except, we aren't the only ones who use tools. A lot of animals, mainly primates, use tools for all kinds of reasons. A study by Jane Goodall on African chimpanzees would change the definition of man forever. In the research, it was discovered that these chimpanzees use tools to gather food, brush their teeth, and even more. So in response, would this mean we must now redefine man or redefine tool? They use tools for the exact same things we would. Do we accept chimpanzees as human? Well, of course not. This begs the question, if using tools doesn't, then what makes us human? In the same research, it was also discovered that chimps had individual personalities and were capable of rational thoughts like emotions and sorrow. They gave pats on the back, hugs, kisses, and even just messed around with each other just for fun. They developed affectionate bonds with family members and with other members of the community, and some of these bonds lasted for over 50 years. If emotions, rational thought, and affectionate actions do not, then what makes us human? In the past, it was thought that humans were the only animals who were self-aware. However, in the past 30 years, extensive research has proven that many other animals are too. In fact, in 2012, a group of neuroscientists created the Cambridge Declaration on Consciousness, which states that humans are not unique in possessing the neurological substrates that generate consciousness. Non-human animals, including all mammals and birds, and many other creatures, also possess these neural substrates. If consciousness, sentience, wakefulness, and the ability to feel and experience do not, then what makes us human? We really just don't know. All we know is that one day we weren't, today we are, and one day we will be no more. We don't know what happened before we existed, and neither do we know what will happen after we die. If a person dies and comes back to life, it's referred to as a near-death experience, because we see death as a finality. But what if it isn't? What if one of the beliefs of humanity's many religions is true? Even the Earth itself can be very weird, and sometimes you just see formations that make no sense. Like, who built Stonehenge and why? The same goes for the pyramids. Some people think the gods of Egypt made the pyramids, others are convinced it was made by human effort. But, in reality, we just don't know. The human mind is everything. All of man's greatest inventions, theories, and discoveries have all come from a human mind. We first conceive of an idea in our mind before we can ever create it in the real world. But perhaps, we don't yet know or understand exactly how powerful the mind can be. The placebo effect gives us a glimpse. I made an entire video about the placebo effect, but basically, doctors appear to give a patient treatment, but in actuality, they don't. However, this fake treatment registers in the brain, perceives it as real, and kickstarts the healing process. Basically, the mind heals the body because it thinks the body is getting treatment, even if it isn't. In research on social, cognitive, and affective neuroscience, it was discovered that self-affirmation helps to maintain a positive self-view and helps to restore your self-confidence and self-worth. Simply by telling yourself nice things, it is indeed possible for your mind to convince your brain and body that you are those things. And these are just the things we know the mind is capable of. Think about everything we don't know. There are a lot of things we know about animals. Dogs are sweet and loving, cats can have an attitude, and the lion is apparently the king of the jungle, even if it lives in the savannah. Not everything makes sense, and we really don't know as much as we think we do. Going to space is one of man's greatest achievements. However, what space exploration has clearly shown us is just how small we are in the grand scheme of things. There are at least 2,500 other solar systems that have been discovered, but that number could go up to the tens of billions. We just can't know for sure. That's just in our galaxy, the Milky Way, and the Milky Way is just one of billions of galaxies that are out there. It's so incredibly massive that you just can't help but think, are we alone in the universe? And if we aren't, why hasn't anyone said hi? We have ideas, but as always, we don't know, and we really can't prove most things. A very fundamental question for nature is, what exactly is the universe made of? And why is there stuff in it to begin with? We know that almost all matter is made up from indivisible atoms. But why? Why do atoms exist, and where do they come from? When we die, what exactly do those atoms become? Everything else? At this point, you've listened to me talk for about 7-8 minutes. Time is persistent. For everything with mass, time never stops. We all know that yesterday is in the past, today is the present, and tomorrow is the future. But what exactly is time, and where does it come from? Even more confusing is, did humans discover or invent time? There are so many things about the world that we just don't know. And while some are deep questions like we've talked about, others are more, well, trivial. While watching the video of this person yawning, you probably also yawned. So even more importantly, why is yawning contagious? When we're happy, we laugh. When we're sad, we cry. But why? For a long time, it was believed that laughter was a social tool to show one another that we're enjoying what's currently happening. It was an evolution tool used to help enhance connectivity in societies. But if that was the case, then laughter should be unique to us humans, or at least primates. But it's not. Other social animals like dolphins and even rats laugh. So why do we laugh? Also, why do we cry? It's as if crying has emotional healing powers. Crying activates our parasympathetic nervous system and helps return our bodies to a normal, fully functional state. It's a good thing for your body, so why do we associate it with such sad things? We often cry after something bad has happened, not really while it's happening. Is it a process that evolved solely for our brains to process emotionally painful things? Then again, we cry for happy reasons as well, so scratch everything I just said. Why are some people right-handed and others are left-handed? Why isn't everyone ambidextrous? Wouldn't that have made a lot more sense? We can have theories for many, many things, but they remain just that, theories. In actuality, proving theories as a fact of nature is a lot harder than you'd think. Many scientific theories are superseded with time, considered obsolete, or simply wrong. We used to think that Earth was the center of the universe. Then one day, we realized it wasn't. Then again, not everyone could accept the fact that their view of the universe was so wrong. I mean, there's a theory that as recently as World War II, the Germans attempted some advances under the impression that the Earth was hollow. So, it is very possible that mostly everything we do know about the world right now is wrong. Honestly, it probably is. We simply don't know everything about everything. And that's okay. All we can do is keep asking questions and keep learning about the world around us, trying to uncover each of its mysteries one stone at a time, hopefully answering the most important question of them all. What does existence truly mean?
The cosmic layer, from Earth to infinity and beyond. And now we look up, beyond ourselves, past our thoughts, and into the stars. The universe stretches out farther than we can possibly imagine. Since we could look up, we've wondered what lies beyond the clouds. We've flown close to the sun to find out, sent messages into the ether, and put our footprints on the moon. Yet, for every time we've called out, we've received nothing in return. Not a shout, not a bang, not even a whisper. We are left with the consuming dread of the vastness of our universe and the terrifying reality that we could be the only ones here to experience it. This is the cosmic layer, the edge of what we can ask, and the beginning of what we can't.
Have you ever looked up at the night sky and pondered about your very own existence? Maybe you were camping out with some friends, or all alone marveling at the big canvas of darkness plastered with countless glowing stars. Well, you're not alone. Looking above and contemplating the sheer immensity of the universe is something humans have been doing since the dawn of time. It's quite magical that recognizing you're part of something inexplicably huge and impersonal can elicit feelings that are so deep, reflective, and personal. Whenever you find yourself lost in these pensive moments, know that the universe, this ancient organism that we were somehow born into, is calling you on a spiritual journey that is in one way or another meant to guide you through your deep and existential emotions and help you find your place in its cold yet comforting grasp. The ancient Stoics understood precisely how immense our human problems could feel. They knew how a bad day at work could develop into a week of aggravation. They knew how a string of bad luck could become a gateway to depression. But they also knew how insignificant our problems really are in the grand scheme of things, and that once we fully understood this cosmic scale, we would truly become free. So if you're having a bad day or you just feel a bit out of sorts, find a quiet place and prepare yourself to witness the view from above for the first time. You're about to embark on a journey outside of your own body, a celestial adventure meant to help you understand the sheer size of our ever-expanding universe, and in the process, your place in it. Because only when you look above will you be able to understand what's within. So take a deep breath and close your eyes. Your journey across the universe is about to begin. Wherever you are right now, imagine yourself slowly lifting out of your body and floating in the vicinity of the room you're in. Observe your surroundings. You're no longer confined to the borders of your own body. Can you see yourself sitting there with your eyes closed, taking deep breaths? Looks weird, right? If you think about it, no one really knows you like you know yourself. People's perceptions of you are based on their own interactions with you. They have their own biases and judgments, and while some of them come close to knowing who you really are, none of them ever fully do. Floating around in your room, you can finally experience your true self. You can observe your body without being inside of it. The room you're in all its familiarity, could very well feel alien to you right now. You may have grown up in this room, spent years developing your sense of self, and yet, as you float around, none of it feels it's genuinely yours. As the abstract feeling of detachment swirls through your mind, you suddenly zoom out to observe the countless houses in your neighborhood or the endless apartments stacked in towering skyscrapers. People just like you wake up every morning and carry on living in the same houses, growing up in the same streets and leading similar lives. It's funny how we can be so physically close to each other and yet know nothing of one another. How many people live in your town or city? How many of them do you really know? What are their dreams and ambitions, their fears and insecurities? Do you think they're that different to yours? We tend to think that our human experience is so unique that no one, not a single person out of the nearly 8 billion of us on this planet, can begin to understand what we're going through. But the truth is, we're a lot more similar than we believe, and that should give us solace in the face of adversity. Look at the houses in your neighborhood, or the buildings stacked elegantly next to each other. They are all the same. As you witness this view from above, your heart will begin to fill with an unexpected warmth as you feel connected to every one of the humans inside those houses. It's like a piece of you lives in every single one of them. A lot of the towns in the US have populations of 1,000, and yet we still call them small. But aren't 1,000 people a lot? Try and imagine that number on a football field or a basketball court. Are these towns still considered small in your eyes? The United States is actually considered a nation of small towns. Out of a population of around 330 million people, data from the past decade shows that 3/4 live in cities and towns with fewer than 5,000 people. So I ask again, is 1,000 small? Continue to zoom out and you see the towns and cities that make up states bound by imaginary borders. Or are they really imaginary? There's around 40 million people living in California, basking in the golden sun of the Pacific Ocean. On the other hand, there are only about 732,000 people living an entirely different life in the cold of Alaska. The life of a Californian is very different from that of an Alaskan, even if both are just humans trying to make the most out of their puzzling existence. Our history has also drawn some real blood-stained boundaries, separating us and forcing us to focus on our differences rather than our similarities. Wars have claimed millions of lives, mostly in the names of ideologies of separation and alienation. As you slowly travel the globe from the American continent, you see how life can develop completely differently despite proximity. Throughout history, many countries fought internal civil battles and subsequently declared their own independence. South Sudan declared independence from Sudan in 2011, Kosovo declared independence from Serbia in 2008, and Montenegro became its own state after separating from Serbia in 2006. Many more have separated and declared their independence, which makes you wonder how defined we are by the countries we're born into. Are you still breathing? Your journey through planet Earth is almost over. You've lifted from your body, away from your hometown, out of your home country, and now you're floating in the atmosphere of our tiny blue planet, perhaps aboard the International Space Station. In 24 hours, this tiny space station orbits our planet 16 times. 16 sunrises and 16 sunsets. Imagine looking at the Earth as you orbit its 40,075 kilometers, or around 25,000 miles circumference. Except for the moon landing, everything that has ever happened in the history of humanity has happened on this planet. Everything we've ever experienced, every joy, every disappointment, every love, every broken heart. Our entire human existence is presently confined to this rotating globe floating in the vastness of space. And as it rotates at 16,075 kilometers per hour, time passes and washes away all that ever was and makes room for whatever there is to come. Our planet has existed for 4.5 billion years, but us modern humans have only been here for around 200,000 years, and civilization as we know it is only around 6,000 years old. You and me, if we're lucky enough, will only get to experience around 80 more of those years. Everything that has happened before and everything that will happen after, we can only imagine. The burden of our existence is nothing but a speck of dust in the cosmic hourglass. Looking at Earth from above could be daunting. Astronauts that live on the ISS almost always come back to Earth with a fundamental understanding of what it truly means to be alive, and what matters most in life. Take another long and deep breath. Let your lungs fill with the magnitude of what you've already experienced and what you're about to experience. You're going to journey further into space, deep into our solar system, and then into uncharted territory where no human has ever traversed. Leave all your human preconceptions behind and open your heart to the expanding universe. As you finally break free from the Earth's atmosphere, imagine yourself floating further to the edge of interstellar space, looking at our solar system as a whole. 8 planets circling around a glowing star. Each one of these planets has its own unique story, from Saturn's ringed beauty to the massive bulk of Jupiter and its great red spot big enough to engulf the entirety of Earth. But even Jupiter's incredible mass holds no candle to the centerpiece of our glorious solar system, the Sun, the star that holds our collection of planets together. Our Sun is 109 times wider than Earth and makes up 99.8% of our solar system's entire mass. Put everything you've experienced in the scale and then compare it to the sheer magnitude of our glowing star, and let it sink in for a second. Let's take a step further and slowly leave the safety of our solar system. Observe as the Sun itself becomes a small particle, barely visible from our astronomical vantage point. You look around you and notice the countless other stars, billions of glowing specks everywhere you turn. There are more stars in the universe than there are grains of sand on Earth, more than 10,000 stars for each grain, in fact. Most of these stars have planets orbiting around them, just like our solar system. If the primordial soup that spawned life on Earth managed to replicate on one of these countless planets, would it be similar to life as we know it on Earth? Would they wonder about their existence the same way we do? Would they understand how small and insignificant their problems are in the grand scheme of things? Imagine alien civilizations fighting through their own existence just like you and I. Imagine the struggle to exist in the universe every day. Planets that harbor life, that orbit stars, that make up galaxies that float around alone in space. You are now leaving the Milky Way and venturing further out into the still and silent darkness of the universe. Everywhere you look, there's a galaxy waiting to be explored. A galaxy that could harbor a star, that might have a planet that somehow managed to produce life against all odds. One more deep breath, and you're now looking at the entire observable universe. One big organism that is at least 92 billion light years wide. Now that you've been able to observe the universe as a whole, it's time to slowly bring it all back in. Let's find the Milky Way among the hundreds of billions of galaxies out there. Let's find our Sun among the 100,000 million stars in our home galaxy. We're finally back in the solar system, passing from Neptune to Saturn to Mars, and finally Earth. You jump from the ISS and burst through the atmosphere and then cross the imaginary borders that are meant to separate us. Find your country, your state, your street, and then your home. Finally look at yourself breathing, taking all that experience in. Take one last deep breath and open your eyes. Next time you're feeling down or the world seems to be taking too much of a toll on you, contemplate your existence and remember this moment, this feeling, this experience. Let it remind you that whatever is weighing you down is only temporary. A minor setback in the grand cosmic scale.
Some of them very likely have planets, and therefore I can imagine civilizations immensely beyond the capabilities of our own.
NASA just announced the discovery of 500 new planets. They're all orbiting other stars.
Our place in the universe is relatively quiet. We have an average star orbited by 8 planets, one of which contains us. For every grain of sand on Earth, there's 10,000 stars up in the sky. To be exact, sorta, there's between 10 to the 22 and 10 to the 24 total stars. Let's say that 5% of those stars are like our own sun. That leaves 500 billion sun-like stars. Alright, cool. So let's say that 1 in every 5 of those stars have a planet in the Goldilocks zone, a region around a star that can allow for liquid water, and life as we know it, to exist. That leaves 100 billion Earth-like planets out there. Okay, good. Out of these planets, let's say that 1% of them actually have life show up. Then, every single grain of sand on Earth would then represent an Earth-like exoplanet with potential life. Using this math, there's about 100 billion stars in the Milky Way, meaning that there's over 1 billion Earth-like planets in our galaxy alone. If 1% of those planets have life show up, then there's possibly between 100,000 and 1 million civilizations somewhere in our galaxy. SETI, the search for extraterrestrial intelligence, has been searching for these signals for decades, but out of all of these possible civilizations, we've heard back from exactly 0. So, where is everybody? The Fermi paradox addresses this exact question. If there's so many stars out there, if there's so many planets that are like Earth, why haven't we found them yet? Or why haven't they found us? Planets are actually really common in the universe. In just the past couple of years, our knowledge of habitable exoplanets, planets like Earth that exist outside of our solar system, have shot up drastically. We're now aware of around 3,800 exoplanets, some of which could possibly harbor life. The TRAPPIST-1 system is thought to have 7 habitable planets orbiting a star about the size of Jupiter. The worlds are rocky, they have water. Earth is just like them. Okay, so if there's all these planets like Earth that could have life, why hasn't at least one other civilization other than our own been detected? Even though we continue to search for life every day, we've been acting like it already exists for decades. For example, when we first went to the moon, the returning astronauts weren't able just to walk around and go to press conferences like they do today, but instead they were locked in quarantine for weeks. Why? Well, it was assumed that if there was life on the moon, not developed life, but bacteria and microbes, then that could pose a serious threat to life back home and potentially wipe us off the face of the Earth. Seriously. It was a serious enough issue and concern that the practice was continued throughout the Apollo program up until Apollo 15, when we realized we were okay. But that doesn't account for humans contaminating other moons or planets. There's quite literally thousands of pounds of junk just lying around on the moon. Although it's unlikely, it is possible that there could be bacteria on those objects that may be able to live under those circumstances, and we may have provided the moon its first life forms. The reason why we send satellites into the atmospheres of planets to burn up after we're done with them is for this exact reason, to prevent us from spreading ourselves places we shouldn't be. As bad as it sounds, every prediction we've ever made about the universe in the past has ended up being wrong in some way or another. There's been about 100 billion people throughout the entirety of humanity's existence. Almost all of them died without knowing what the planets actually were, what the universe is or was. 99% of all species on Earth have died already. Are we gonna be the next one? Hundreds of years ago, we believed in a geocentric theory and thought that everything in the universe revolved around us. We believed the Earth was flat, but today we obviously know these things are the furthest from the truth. So based on our track record, it would be dumb to assume that we're the only life in the universe. Frank Drake thought the same thing. He thought, there's absolutely no way we're alone in the universe. There must be a way to calculate where everyone is, right? And from that simple question, we now have what is known as the Drake equation.
Discovery Houston, 20 seconds to LOS.
Roger, 0G, I feel fine. Capsule is turning around.
The Drake equation breaks down all the necessary steps and requirements for a civilization to exist and thrive on a galactic level, allowing for us to detect them. It breaks down the search step by step, and at the end, we're left with the number of civilizations out there, waiting to be found. This is the Drake equation. In a single line, 7 variables, when multiplied together, give us a way of measuring how many possible civilizations could exist in our galaxy at this very instant. It's an actual way of calculating what we did at the start of the video, and there's terms for each step. It's a little daunting, but I'll break it down. N is the number of civilizations in our galaxy that we have a chance of talking to. This is what we're trying to figure out. Our star is the average rate of star formation in our galaxy. Now, we don't know the exact number of stars that form every year, but we do know the amount of solar masses that form every year. It's about 3. So every year, about 3 average-sized stars form. Luckily, our Sun is a pretty average star, so it's a good way to view it. It could be one huge star or 10 smaller stars. We don't know for sure, but this term in the equation is the one that we're the most certain of. F sub p is the fraction of those stars that have planets. This number isn't certain, but some people have estimated that it's somewhere between 10 and 50%. Not super accurate, but it's a start. N sub e is the average number of planets that could potentially support life. So first we find the stars, second we find the planets, third we find the planets out of those that could support life. As I said at the start of the video, about 1 in every 5 stars have a planet in the habitable zone, so this is pretty certain as well. F sub L is where things start to get a little bit messy. F sub L is the fraction of planets that actually develop life at some point. Our data on life is really small, and by really small I mean us. We have 1 planet's worth of information on life out of the billions of planets out there in the sky. We're just going off the data that we have, but what if extraterrestrial life doesn't function even close to the way that we do? It's possible, and I think quite likely, that life beyond Earth doesn't always need water or oxygen or sunlight at all. They don't have to function the way humans do. There's trillions of planets in the universe with trillions of different living conditions, so it's only fair to assume that there's possibly trillions of circumstances that allow alien beings to survive. So F sub L is hard to determine. F sub I is the fraction of planets with life that can actually form civilizations like we have. Again, our data is limited to us and only us. Something I really think about a lot is, if we live on such an average planet in an average galaxy around an average star, how did we get so lucky to be the only life to exist? If everything else around us is average, why did the anomaly known as life pop up here? Or maybe life in general isn't an anomaly, but just intelligent life is. Life that is able to ask the kind of questions like, are we alone? Out of all the species on Earth, us humans are the only ones who have developed language. Alien methods of communication might not even be imaginable by us. They might not even have language or gather information visually or through the senses that we have, or even have any way of conveying things to species other than its own. It's like humans trying to understand and speak whale. I don't know how to, and I don't know anyone else that does. The same logic may apply to extraterrestrial beings and how they communicate. How many other life forms on Earth actually have verbal means of communication other than us? When we discover ancient languages, we have ways to decipher them. We have ways to make connections to other languages. We know how sentences are structured in various ways. With alien languages, there's nothing to refer to. We can refer to our own languages, sure, but cross-referencing entire civilizations on opposite ends of the galaxy with our own human language seems counterintuitive. F sub c is the fraction of civilizations that develop technology that can be detected. We, again, are the only examples of this. Let's say the Earth was created 1 year ago. Humans would then only be about 10 minutes old. The Industrial Revolution would have happened only 2 seconds ago. For the majority of human history, we have had literally 0 ways to even consider contacting alien life. It's a very, very recent thing. We've been broadcasting radio waves into space for the past 100 years, but humanity has been around for as long as 1 million years. Out of our entire existence, only 0.0001% of that time have we even been able to conceivably contact aliens. Also keep in mind, radio waves are the only way that we've tried so far. In 100 or 200 years, we may find another way of contacting extraterrestrial life that could work millions of times better than radio waves. This could also be a reason why we haven't heard anything back. It would be like trying to talk to someone across the world via carrier pigeon while everyone else is using the internet. You would just look stupid. See, we expect all civilizations to be using the same kind of technology that we do. The only problem is we're either A, the first to get technology of our scale, or B, we've fallen behind and everyone else ahead of us is only getting more and more advanced. However, if they are able to detect our radio waves, they may have already found them.
Discovery's 4 computers now have primary control of critical vehicle functions.
See, the last term in the Drake equation is L. It tells us how long a civilization lasts. It represents how long we have to be found before it's too late. Extraterrestrial civilizations may send out signals for a long time until they stop, or destroy themselves, or find a better way to live. A life in a simulation, perhaps. The longer L is, the more advanced the civilization becomes. The Kardashev scale comes in handy here. I made an entire video on this topic, it's really bad, but I'll explain the important parts here. First, a civilization needs to find a way to take over its planet. This is called a Type 1 civilization. We're on our way there, we're at about 0.72 at the moment. A Type 2 civilization is capable of harnessing the power of its entire host star. See, the further away you are from a star, the less energy you get from it. Earth only gets maybe 1/1000% of the sun's energy at any moment. Many structures have been proposed to somehow harness the sun's energy, but we won't be there for a very, very long time. The third stage for a civilization is, you guessed it, a Type 3 civilization. This civilization has conquered the galaxy and has access to any and every planet. But from our knowledge, there isn't even one of those civilizations out there that are detectable, and that doesn't make sense. See, the universe is 13.8 billion years old. Earth has only been around for maybe a third of that. There's been at least 5 billion years prior to Earth coming into existence that could allow for civilizations to have risen and also fallen. But yet, we see nothing. If you could build a device, a huge ship, that could travel at 10% the speed of light, you could cross the galaxy in 600,000 years. I know, it sounds like a long time, but in comparison to the Milky Way's at least 10 billion year old age, 600,000 years is literally nothing. All it takes is for one species to do this, and they could cover the entire galaxy. So if it's that easy, why haven't we seen it yet? Well, it might be a good thing, because that would mean that the Great Filter is in front of us. There may be other life in the universe, but there's barriers that we all have to overcome. The Great Filter theory helps explain this very well. Imagine that there's 1 million civilizations in the Milky Way galaxy, but not all of them can thrive to the point that they take over the galaxy. There's barriers in the way. These barriers are things that new lifeforms and civilizations must overcome. The first barrier might be multicellular life, and maybe that's an easy barrier to cross. Okay, next barrier. The ability to have thoughts and a consciousness. Next, maybe we have to understand basic technology. Okay, that's fine, we're good at that. Next, discover time travel. Okay, not so easy. We're kinda stuck. See, there's things that prevent us from progressing, moving forward and becoming a galactic civilization, but we don't know what those things are. There's hundreds of billions of planets in the Milky Way, but when we look for other life, there's nothing. Where's it all at? Well, the Great Filter theory shows that there's certain steps that the species must get past in order to take over their planet, solar system, galaxy, and so on, just like the Kardashev scale suggests. One, or perhaps multiple of these filters are extremely hard, or maybe impossible to get past. The question is, have we already gotten past that barrier, or does it lie in front of us? If it's behind us, then good. We've passed a nearly impossible step in building a civilization, and we may be one of, or even the first advanced civilization in the universe. If it's ahead of us, then we have our work cut out for us. For the majority of human history, the planet's fate was up to events that humans couldn't control. For example, large asteroids that wiped the planet of its inhabitants. But today, actually only in the past 80 years, we've developed technology capable of ending human civilization at a moment's notice. We're working on AGI that will then lead to superintelligent AI. These could be some of the barriers we must get past, and it may be where many civilizations fail. If we find an advanced civilization that has died in the process of advancing, then the Great Filter is in front of us, and this isn't good. The Great Filter is a challenge that wipes out almost every species that encounters it. It's not just one that kills off 99% of a population. That would give them a chance to regrow and reconquer that barrier. This would kill 100% of every civilization that has ever existed, and leave no chance for repairs. As with many other things that people believe to be stronger than them, things like superintelligent AI or aliens, many people tend to fear them. Historically, whenever a stronger species or civilization, or, for the future's sake, technology arose, it almost always resulted in the weaker party being wiped out. For example, humans and Neanderthals, or more recently, the discovery of North America. Perhaps this is only human nature, but based off of what we know from the past, first contact with aliens might be the most dangerous thing humanity has ever faced. A really important question arises here. If we do hear from or detect another civilization, should we let them know that we heard it? The futurist half of me says yes, of course, but the other half of me says maybe not. This could be exactly what alien civilizations are doing right now. It's possible that they have detected us already, but instead of responding, they're observing and patiently waiting. Advanced alien species may just be observing us to see how we progress. Consider us a science experiment, but on a potentially galactic scale. I touched on this in my AI video, but I'll bring it up again here. When you're building or observing something or someone who could be multiple times more powerful than you are, you need to be careful. You want to observe and keep a close eye on how it progresses. AI could help us colonize the galaxy and meet other life forms, but it could also cause the extinction of our species. What happens if superintelligent AI sees extraterrestrial life as a threat and makes attempts to take it out? It'll probably fail, and that is one of the worst scenarios for us. One of our own creations, perhaps our best creation, is the cause for the extinction of our species. But with the case of AI that we're developing on our own planet, if it gets too powerful, we'd just shut it off, right? Type 3 civilizations may be doing the same thing with us. They may be observing us to see how other life in the universe becomes powerful, and if we eventually get to that tipping point, whatever it may be, they may decide to put an end to their experiment. It sounds insane, but we do that here on Earth. There are parts of Earth that we could inhabit, but we don't just because it isn't convenient for us. Prime example, Antarctica. It's an entire continent that we don't colonize because it isn't convenient. It's frozen and just not super suitable for life. This could be how alien civilizations view Earth. They may have found us, realized that we aren't special at all, and moved on. For all we know, we may have already been visited by aliens, just not recently. With all the time before Earth's formation that may have allowed civilizations to form, there's a chance that one or maybe multiple of those civilizations have stumbled upon Earth during its infancy, when there was no life to be found. Modern humans have only been around for maybe 50,000 to 100,000 years. 100,000 years out of 4.5 billion is practically nothing. In an entire galaxy, there's bound to be places that just aren't worth colonizing. Why waste time and resources on colonizing a planet that won't benefit you in any way? Aliens wouldn't come to Earth without a reason, whether it's good or bad. Drake's equation is just that, an equation. The terms, mostly the last four, are educated guesses at best. That's all you can really do when trying to answer a question of this magnitude. There could be many, many more civilizations than we think. Or maybe we're the only one. If any of the values in Drake's equation end up being 0, that's it. We're alone. There's been many calculations made with the Drake equation, and it all comes down to how pessimistic or optimistic you are about the future. There have been calculations as high as a couple million civilizations in our galaxy, and there have been calculations that say we're alone. And at the moment, they both hold value. Enrico Fermi did ask one of the most important questions humans have ever asked, but at the same time, Fermi was also a pioneer in the creation of nuclear weapons. The species that could inhabit the entire galaxy is also the same species that stands capable of almost completely wiping itself out at a moment's notice. We search every day for signals from other civilizations. We look for techno-signatures, signs of engineering, of things that just don't commonly appear in nature, like city lights from space. We search for those in other corners of the galaxy. We study biosignatures in the atmospheres of exoplanets to find elements that may show that life could exist. We sent out radio waves hoping to find aliens. In 1974, Frank Drake himself sent out the Arecibo message to the M13 star cluster. It's a string of information describing humanity in hopes that someone, or something, would find it. We send out satellites such as the Voyager crafts, with specific instructions of who we are, what we are, and where we are. We're doing all we can to find alien life, while also giving them all the information they need to find us. We want so badly not to be the only ones in the universe that we don't even consider the possible consequences of us not being alone. Are we done, or are we just getting started? I guess the better question is, are we closer to the beginning or the end of human existence? There's only a finite amount of space on Earth for life, and there's only one place we can go. Either way, the clock is ticking down. Time is against us, and I don't want to be around to see what happens when that clock hits 0. So imagine you're Usain Bolt. You're like 6.5 feet tall, you have a couple Olympic medals, no biggie. You show up to your final Olympic race, and your only opponent is a tortoise. For some reason, he has gold medals around his neck, he can talk, and he challenges you to a 100-meter race. You're confused, but you accept his challenge. His only condition is that he gets a 50-meter head start. I mean, seems fair, right? He is only a tortoise. So you line up at the start of the race, the gun goes off, and the tortoise begins his 50-meter head start. It's gonna take a while, so feel free to get a coffee, go home, take a nap, just do whatever you want. After a while, he finally gets to the 50-meter mark, and you sprint up to catch up with him. But in the time that it took you to get to the 50-meter mark where the tortoise was, he's moved forward another 10 meters. No problem, you just have to catch up to the point where he is now. But wait, once you get to that point, the tortoise has moved forward another 5 meters, so you have to catch up again. This process continues to repeat and repeat an infinite amount of times. We can continue cutting the distance between you and the tortoise in half as many times as we want. They all take a finite amount of time to complete, but the distances can continue to be cut in half forever. Let's say it takes you 5 seconds to run the initial 50 meters, then another 1 second to run the extra 10 meters, then another half a second to run the next 5. All of these times are finite, but there's an infinite amount of distances you have to travel. So by this logic, it should take an infinite amount of time to catch up to the tortoise, right? You can never catch up to the tortoise, and in the end he beats you in the race. It makes no sense, but this logic says you literally cannot pass him without doing more than an infinite amount of tasks. Not only can you not beat the tortoise, but you can't move anywhere without doing an infinite number of tasks, and thus movement from your bed to your refrigerator should take an infinite amount of time. So was our math wrong, or is motion impossible? Clearly, this argument is insane. I mean, race any tortoise in the world and you'll beat it in a race every single time. But where's the flaw in the logic? This is known as one of Zeno's paradoxes. There's multiple, but they all address the same thing. Motion, as we know it, is an illusion. The thought is, in order to finish the race, or really any movement in general, you'd first have to get halfway between your starting point and the finish line, which in the race's case is 50 meters. From there, you'd have to get to the halfway point between the 50-meter point and the finish line, the 75-meter point. This continues being cut in half an infinite amount of times. This idea can also be reversed, and this is where things get interesting. If we reverse the sequence, what number comes first? We can't start at 50 because we can divide that by 2. We can't start at 25 because we can divide that in half as well. In fact, we can divide any finite number in half an infinite amount of times. This means that there is no first distance to run, therefore making motion impossible? Or maybe not impossible, but just an illusion. The idea was that because there's an infinite amount of distances being added, they must take an infinite amount of time to complete, right? And not really. Zeno was wrong to assume that there's an infinite amount of distance to traverse. Calculus kinda solves the problem. With the example of the 100-meter race, cutting the distance in half each time just creates what is known as a convergent series. When you add all of the infinite amount of terms in this series together, you don't get infinity, you get 100, the total distance of the race. All of the terms, when added together, converge to 100, and this solves the problem of infinite distance. But what about the race versus the tortoise? We obviously know that you'd pass the tortoise during the race. But how? If you run at 10 meters per second while the tortoise only moves at 2 meters per second, well, after his 50-meter head start, you'd pass him in a little over 6 seconds. Although there isn't an infinite amount of distance to travel, there are still an infinite amount of tasks you must perform to pass the tortoise. Like we just saw, the math works out to be just fine, but the logic behind it doesn't. How can you do an infinite amount of things in a finite amount of time? Supertasks. Supertasks provide us with a way of doing infinitely many things in any amount of time you desire. It's a countably infinite sequence of operations that occur in a finite amount of time. Countably infinite is really important. It'll come in later. To explain this, we'll use Thomson's lamp. Thomson's lamp is a perfect way to describe supertasks. Take a lamp. Lamps can either be on or off. Nothing else. Let's say it was your job to turn this lamp on and off, and your boss says, I need you to turn this lamp on and off an infinite number of times before this hour is up. At first, you probably will consider quitting, but don't. This is entirely possible. First, turn the lamp on, then wait 30 minutes and turn the lamp off. Wait 15 minutes and turn the lamp back on. Continue doing this, waiting half the amount of time from the previous step to do the opposite of what the last step was, turning it on if it was off, and turning it off if it was on. By the time the hour is up, you will have turned the lamp on and off a countably infinite number of times. But the question is, when the clock hits 1 hour, is the lamp on or off? It can't be on because when it was on, it's immediately turned off in the next step. It can't be off because it's immediately turned back on during the next step. So, what's the final state? Or is there even one to begin with? The supertask says nothing about the final state of the object or task in question, but only instead what happens to it during the process. Still, at the end, you will have completed an infinite number of tasks in a finite amount of time. Take the sum, we'll call it n. 1, minus 1, plus 1, minus 1, plus 1, and continue this on an infinite amount of times. What is the sum of this? If you stop it at an even point, it's 0. If you stop it at an odd point, it's 1. But infinite sums don't have a final step, just like Thomson's lamp. So let's make this a supertask that lasts 1 minute. First, we have 1. After half a minute, we subtract 1. After a quarter of a minute, we add 1, and continue this until the entire minute is up. So, what's the answer? It could be 1, it could be 0. But it's actually neither? If we take our original equation and create a new one called 1 minus n, it turns into 1 minus 1 minus 1 plus 1 minus 1, so on. When we distribute the negative, we have 1 minus 1 plus 1 minus 1 and so on. It's our original sum. 1 minus n equals n. Sounds a little bit weird, but no problem. We can solve this equation easily. Just add n to the other side, and we have 1 equals 2n. Divide both sides by 2, and we have our answer. 1/2. This is insane, and we've added and subtracted an infinite number of 1s, and we get 1/2. What does this mean for Thomson's lamp? When the lamp is on, that could be considered 1. When the lamp is off, that could be considered 0. What does 1/2 mean for this scenario? Is it half on, half off? Is it in some other form? Does the lamp just disappear? We don't know. It's also assuming that the answer 1/2 is even correct. See, unlike the 100-meter race, where we cut the distances in half each time, this is not a convergent series like that was. See, after we added all the numbers up for the race, it converged to 100, and that's confirmed, and that makes sense. But with this, it's alternating, 1s and 0s that don't actually ever converge to an actual value. For series like these, it's almost dumb to try and attach a value or a sum to it. But still, the implications for Thomson's lamp stand, and they stand unanswered. We're coming across problems here. We're on the fine line between math and human logic and intuition. Our math may say one thing while our logic says another. Is our math wrong, or is our view of reality just an illusion? In real life, you'd beat the tortoise in a race 1 billion times in a row, obviously. Zeno's argument was that there must be a smallest unit of space possible so that there could be an explanation as to how you'd win the race. A smallest step that couldn't be cut in half again, that would then allow for you to speed past the tortoise and win. And it looks like that might be true. There's actually a smallest physical and meaningful distance in reality, the Planck length, 1.16 times 10 to the negative 35 meters. Any distance smaller than this makes zero physical sense whatsoever. The numbers just don't work with current physics. The realm of quantum gravity dominates here, which is a concept that we don't have an answer for yet. When trying to solve the problems of quantum gravity, or more commonly known as a theory of everything, our equations return us infinite answers, and in physics, infinite answers could not be any more useless. But if we attach a smallest distance in the universe, our results return finite numbers that we can manage. I guess a good question comes up here. Our math that seems universal and works everywhere explains space-time. But does space-time itself explain our math? Imagine a box that can hold an infinite number of balls. You, for some reason, have an infinite number of balls yourself and want to put them into this box. They all have a number on them, all of the naturals, so 1, 2, 3, and so on. Let's say that we have 1 hour to put all of these balls into the box. No problem, we'll just make it a super task. We'll put 1 ball in to start, wait 30 minutes and put another ball in, wait 15 more minutes and put another one in, and so on. Clearly, after the hour is up, we will have a countably infinite number of balls in the box. Perfect. Let's do the super task again, but differently. Empty the box and reset your clock. Okay, this time we're going to put the balls in 10 at a time, but with a little twist. Every time we put 10 balls in the box, we'll remove that ball step number. For example, we'll start the clock and put the first 10 balls in. Since this is the first step, we'll remove ball number 1. After we wait 30 minutes, we put 10 more balls in, balls 11 through 20, and remove ball number 2. We continue doing this at the same rate as before, cutting the time in half each time but still adding 10 and removing 1 at the same time. Now, if we think about it, every time we put balls into the box, we add 10 and remove 1. Therefore, we have a net gain of 9 balls each time, right? You're correct. So, at the end of the 1 hour, we should have a countably infinite number of balls again, right? No. Because we have a countably infinite number of balls and a countably infinite number of steps, there isn't a ball where we don't remove it in a later step. Ball 1 is removed on step 1, ball 10 is removed on step 10, ball 1 million is removed on step 1 million. For a general term, ball n is removed on step n, and since we have an infinite amount of tasks to go through in the 1 hour, this means that by the time the hour is up, there will be 0 balls in the box. Okay, maybe we made a mistake. Let's empty the box again and try it a different way. So the same terms apply. We have 1 hour, an infinite number of balls, and we put them in 10 at a time. Nothing has changed there. Now, instead of removing the ball that is equal to the step number we're on, for example, removing ball 1 at step 1, ball 2 at step 2, and so on, we'll remove the highest numbered ball instead. So ball 10 gets removed at step 1, ball 20 at step 2, and so on. Now, we repeat the process of adding balls 1 through 10 and removing ball 10. Wait 30 minutes, add balls 11 through 20 and remove ball 20. Continue this process for the entire hour, and then we end up having an infinite number of balls in the box this time. This is again insane. Both of these situations we end up having a net gain of 9 balls. But depending on which balls we take out, and in what order, we either have an infinite number of balls or no balls at all. Both sets of balls have the same values. We have a countably infinite number of them at the start, but yet the order that we put them in and remove them from the box affects the outcome. This will be very important later on. This goes against our intuition, and even now saying this, it still doesn't make sense. But it is true. The idea of infinity, infinite sequences of numbers that go on forever, end up causing so many problems and kind of make us question everything. It's not a number, it's an idea. Infinity isn't a number, but numbers are infinitely big. It's a definition, you can't assign a value to it. As weird as it sounds, some infinities are literally bigger than other infinities. And I'm gonna show you how. Hey, it's me from the future. Just realize that this is really hard to wrap your mind around, and if you have to watch it a couple times to understand, don't feel bad about it. I'll link to videos in the description that explain these topics pretty well. Michael from Vsauce has a really good video explaining this that I highly recommend you watch after this. Counting is pretty easy. You could count to really any number you want if you had all the time in the world. For example, if you wanted to count to 1,000,000 and counted at 1 number per second, it'd take you about 11.5 days. It's a little long, but manageable. However, counting to 1,000,000,000 is another task. If you were to count at the same rate you did when counting to 1,000,000, it would take you over 31 years to count to 1,000,000,000. And 1,000,000,000,000? 31,000 years. If you started counting the second you were born, you'd only end up being able to count to about 3 billion before you die, which is honestly a really small number. Remember before when I mentioned countably infinite numbers? It's an actual thing. If you had an infinite amount of time, you could count out all of these countably infinite numbers. It sounds confusing, I know, but hear me out. The natural numbers, 1, 2, 3, and so on, are countably infinite. You could go on forever just counting them off. But what's weird is that the integers, which are all of the natural numbers and their negative counterparts, are also countably infinite. But logically, that makes no sense. There should be double the amount of integers as there are naturals, right? Well, not necessarily. If you line them up side by side, it's what is known as a bijection. This means that you can pair them up, 1 to 1. Both sets have the same cardinality, which just means they have the same number of elements, or cardinals. Cardinals are just a number denoting a quantity, like 5 circles, 2 rectangles, and so on. However, if we were to label these objects and try and put them in order, denoting the order of these numbers are an entire different type of number, ordinal numbers. To put it simply, ordinal numbers order things. Cardinal numbers represent quantities. For example, the first ordinal number is exactly that, first, then you have second, third, and so on. It represents order. You wouldn't say you got 4 placed in a race, so you got 4th. 3 people finished before you, and we can put them in order properly. You wouldn't say you have 7th balls in a box, you have 7. Going back to natural and integer numbers, it goes against your intuition, but with integers you can go off to infinity in both directions and still have the same number of elements to pair up with the naturals. It's not the traditional way you'd imagine to list out the integers, but it works out perfectly. There's also the same number of even numbers and odd numbers as there are both integers and natural numbers. They're all the same size. Using the same pairing method as before, it works out perfectly. If you were to count forever until the end of the universe, 1, 2, 3, and so on, you would finally reach the smallest infinity there is. Aleph Null. Aleph Null also isn't a number, it just represents the number of counting numbers there are. It behaves like one, except not really. You might think, oh, I can make a larger number than Aleph Null, just Aleph Null plus 1, right? No. Aleph Null plus 1 is still Aleph Null. Aleph Null divided by 2 is still just Aleph Null. You could add another Aleph Null's worth of elements to Aleph Null and still the entire set would only have Aleph Null elements in it. It's like when people say infinity times infinity is just infinity. Although we can add any number of more elements to our set and still have Aleph Null elements, the order that we number them in is very important. See, if we have an Aleph Null worth of circles and then add another one, how do we label this one? There's still just Aleph Null circles here. Remember, Aleph Null is a cardinal number, which represents the quantity of circles. But if we have to label them in order using ordinal numbers, what value do we give this one? A countably infinite number of circles appeared and then this one did. So we need an ordinal number that extends past the finite numbers. This circle is labeled with the first transfinite ordinal number, omega. Up until this point, cardinal numbers and ordinal numbers were the same in the land of the finite. But here, in the infinite, they split off into 2 very different things. This circle, omega, isn't a bigger number than Aleph Null, it just comes after it. Omega plus 1 comes next, omega plus 2, and so on, up until omega plus omega, or omega times omega, or omega to the omega to the omega to the omega, blah 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 blah. It sounds really confusing, but there's still only Aleph Null elements in this set. Ordinal numbers just give us a way of labeling them in the order that they appeared. Because ordinal numbers are different from cardinal numbers after we reach Aleph Null, they behave in very different ways. Remember, cardinal numbers represent the amount of elements in the set. Ordinals only place them in order. There aren't more numbers here, they're just ordered differently. But there are literally infinities bigger than Aleph Null. Remember how Aleph Null is only the set of all natural or integer numbers? Well, what about the numbers between them? Think about this. Can you actually really count to the number 1? So you start at 0, and then what comes next? A half? Well, it can't be a half because you'd miss a fourth. It can't be a fourth because you'd miss an eighth. It's like the same as the reverse Zeno's paradox. What's the first step? It'd be a 0 point, and then an infinite number of zeros, and then a 1 at the end. But there is no n. Real numbers are numbers that include all other numbers, except imaginary ones. Real numbers include all decimals, all natural numbers, all the integers, all the irrational numbers like pi and e. There are more real numbers between 0 and 1 than there are between the set of naturals and Aleph Null. Remember the pairing method we used before? We can do the same thing here. Just match up the decimals between 0 and 1 to the natural numbers between 0 and Aleph Null. We could literally match them all up 1 to 1 and still have infinitely many more real numbers left over. The numbers from 2 to 3, from 3 to 4, and so on are left without a natural number to pair to. So this infinity of real numbers is literally bigger than Aleph Null. How much bigger? Well, we'll need to take a look at power sets first. A power set just represents the total number of subsets that can be made from a set of elements. Let me explain. Let's take the power set of the numbers 3, 5, and 7. We need to lay out every single way we can arrange these three numbers. Well, we can have a set of 3, 5, and 7. We can have a set of just 3 and 5. We can have a set of just 3 and 7. We can also have a set of just 5 and 7. We can also have sets of just the single numbers themselves, so a set of just 3, of just 5, and just 7. Finally, we can have a set with nothing in it. So adding up the numbers of subsets that we can make from the set of 3, 5, and 7, we get 8 subsets. You might be able to see how power setting a set can give you more elements than your original set, very fast. In fact, it's just 2 to the power of however many elements you had in your original set. For this example, we had 3 elements, 3, 5, and 7. 2 to the power of 3 is 8, the same number of subsets that we calculated by hand. So, as we add more and more elements to a set, the power set of that gets very large very fast. For example, the power set of a set with the numbers 1 to 100 has 10 to the 30 different subsets that can be made from it. That's 10 with 30 zeros after it. And that's just with 100 numbers. The power set of Aleph Null would contain every single set and subset of numbers that there could ever be. It's an infinite arrangement of every single way to order Aleph Null things. Trying to even put into perspective all the real numbers between 0 and 1 is hard enough, but the power set of Aleph Null takes in all the subsets of every number there is. This power set is called Aleph 1, and the ordinal number attached to Aleph 1 is called Omega 1. Omega 1 literally represents a number that comes after every single order of numbers that there are listed before it, and has to represent a collection of things larger than the subset of all numbers. Now, because Aleph 1 is the next cardinal number after Aleph Null, a problem shows up. It is known as the continuum hypothesis. What is the power set of the smallest infinity, Aleph Null? The power set of Aleph Null things is equal to Aleph 1, and Aleph 1 is surprisingly equal to the number of all real numbers there are. Or at least we think. It can't be less because then there would have to be a set of numbers that encase all of the real numbers. Numbers beyond our understanding. Aleph Null represents all the infinity of all natural numbers, the integers, and so on. And Aleph 1 represents the infinity of all the real numbers, which includes every single number there is. Again, not including the imaginary numbers. The question is there an infinity between Aleph Null and Aleph 1? It's a hard question. So hard, in fact, that the only answer we have for it at the moment is that we can't prove it to be false, but we also can't prove it to be true. That doesn't really help at all, does it? You can continue going up and up the list of infinites. There are larger infinities that mathematicians have come up with that put Aleph 1 to shame. But to be completely honest, I'm not confident enough in my understanding to try and explain those. There are infinities so big that it actually hurts me to think about. And I think that is one of the most interesting things about humans. There are things that we can conjure up that physically make no sense in our universe, yet we have still managed to come up with them nonetheless. And we can admit that we don't understand our own ideas. The difference between math and physics is that we aren't limited to physical constraints in math. We have and can literally hypothesize things that cannot be represented in the physical world we live in. Like I said earlier, infinity isn't a thing. It's not a place or a number that you can reach. It's an idea. The biggest of ideas, actually. And ideas push us to further understand our place in the universe that we live in, and perhaps even learn about things that lie beyond our reach.
We humans have built our world on the illusion of certainty. We've measured the length, breadth, and depth of our planet. We've put our flag on the moon and reached for the stars. We've tried to explain everything from the tiniest atom to the entire observable universe. And yet, the deeper we look, the more these foundations slip away. Because for every question we answer, several more spring up. This is a journey through the unknown, from the tiniest threads of the quantum world.